session. We have a packed session with very exciting talks about this journey towards a truly global network for cooperation in neurosciences. Speaking of which, I will invite the first speaker, Ellen Glaves, to talk about building a global network for the solid Earth research. Thank you.
Oh, let's try that the right way. So good morning, everybody. See if I can get this positioned a bit better. Okay, so I'm going to say a little bit about why international collaboration is important and why EPOS is seeking to build its network of collaboration and partnerships. I will say I'm not going to be the only speaker. I am going to hand the floor to Federica because we're going to talk a little bit about a survey that we've conducted as well across a whole range of different stakeholders. So I'm going to say a little bit about, why do we need international collaboration? Why does EPOS care? And I think one of the most important things is that we need to share expertise and we need to understand the lessons learned by a whole range of different stakeholders, both those who collaborate directly with EPOS, but also other stakeholders. And this is why EPOS participates in a whole range of different activities. But this sharing of expertise and lessons learned means that we're avoiding duplication of effort. We're maximizing our use of resources. And this is really important because even this morning I was reading on the BBC about the pressures, the downward pressures on funding for scientific research. So those resources that we do have are becoming even more precious. So we need to maximize the benefit that we're getting from them. But we also want to work together because we want to identify what are the common challenges, where can we come together and share this knowledge, expertise and resources to address some of those things that are important to our own respective communities. And we're going to hear a little bit more about those today in this session. As Zhao said, we're going to hear from a variety of different actors. So international collaboration, I mentioned common challenges. So one of the things we've been thinking about is how do we come together to address those large-scale scientific and societal challenges. So we're thinking about natural hazards, we're thinking about climate change, food security, disaster mitigation, to name but a few. But we're also supporting regional and global policy initiatives. So the UN Sustainable Development Goals, which have already been mentioned a couple of times, the Sendai Framework for Disaster Risk Reduction, but there are a whole raft of other policy initiatives, particularly those that are, high on the list for the European Commission, but also we're thinking at the highest policy levels. So, for example, the G7, which was in Italy in 2024, ministers specifically mentioned the importance of collaboration and the impact this has on research infrastructures and the need for them, to support cutting-edge science and research that benefits researchers worldwide. The QR code here, if you really want to read the ministerial statement in detail, is actually where research infrastructures are specifically mentioned in the ministerial statement from that G7. It also interestingly mentions capacity building and specifically mentions the role of young researchers. So it covers a whole raft of the topics that we've already heard about this week. But also, interestingly enough, I put this in because I thought this was particularly relevant. There's also, in 2024, so not that long ago, the G7 conference on major research infrastructures was actually here in Sardinia. And it was talking about the role of large infrastructure in addressing societal challenges. So again, really important for the role of EPOS. And one of the exemplars was given at that meeting was the Einstein Large Telescope, and we will be hearing from that initiative here today. So I'm not going to say any more about that because I don't want to steal their thunder, but I wanted to highlight the role that research infrastructures and large infrastructures has in policy at the highest level and is actually considered at the highest level. But we also want to work together. We want to move towards common approaches for developing interoperability and to create a unified global framework for the solid Earth. We've been thinking a lot about that, particularly with our colleagues in New Zealand and Australia, where we have MOUs. And part of what we're thinking about is how do we build this common framework for the solid Earth? But the landscape is really complicated. Creating this global infrastructure for the solid Earth, there's a whole raft of initiatives, both at the regional and the global level. I just picked out just a few here. I'm not going to go through all of them, but all of them are actors in the space on the European scale. EPOS is part of the ENVRI cluster. You all know about Orpheus and things like Destination Earth. I think it was Daniele mentioned the European Open Science Cloud this week. So there's a whole raft of things that we are trying to piece together when we're thinking about what does this global infrastructure for the solid Earth really look like, and what does it mean when we talk about it? I mentioned that we have the European initiatives. I already referenced the regional ones outside Europe. So I mentioned Ozscope and Earthscope. Earth Sciences New Zealand. I have to keep remembering, Elisabetta, it has a new name now. But also our colleagues in the US, Earthscope. But we need to be thinking about others. We need to be thinking about Africa. I know Xiao does a lot of work in Africa and South America. So we need to think about how are we connecting more widely with other research infrastructures in other regions. But then there are a whole raft of global initiatives that we need to think about. There's the Group on Earth Observation that's actually fostering open access and sharing Earth observation data. And this includes both satellite and ground-based networks, so is equally relevant for EPOS and for GEO. There's Copernicus. We're going to hear about Copernicus. Lorenzo should be here somewhere in the room this morning. Good morning, Lorenzo. Thank you for joining us. But we also need to think about other initiatives such as the Global Earthquake Model, the Global Tsunami Model. Again, both of these we're going to hear about today. But we also need to think about those wider coordinating activities. GEO is active. Too many hats, not enough time. EPOS is also very active in a number of these community coordinating activities. So the Research Data Alliance, CoData, World Data System, Earth Science Information Partners, all of these initiatives are thinking about standards, best practices that feed into EPOS, but also critically, EPOS is actually influencing what's happening in a number of these initiatives. So we also need to think about where are the touch points for EPOS in these wider initiatives thinking about best practices. But what are the problems? What are the barriers to creating this global framework? One of the biggest issues is insufficient long-term resourcing for large-scale efforts around interoperability, around partnerships. These are particular issues. I mean, and we've also seen some of the geopolitical issues at the moment, which are limiting funding to certain initiatives. Our US colleagues are certainly feeling the pressure of this at the moment. There's a lack of sustained coordination at the global scale, shifting priorities, both scientific and societal, at national and regional level. I'm not going to say any more about that. And just fragmentation and heterogeneity of the global data landscape. But how do we move forward? And we need to create networks across different relevant stakeholders. And actually, the diversity of the different initiatives that's here in the room today demonstrates the importance and the power of creating those different networks across different stakeholders and bringing them together. We need to establish regional and global partnerships and formalize those. And as I mentioned, EPOS is already doing that. We've already done that with our colleagues in New Zealand, in Australia, in the US, and we continue to move forward in EPOS in developing these partnerships. We need to think about organizational memberships. So EPOS, for example, is a participating organization in GEO and is actually influencing what's happening in GEO in terms of the technical infrastructure that is being developed by GEO right now. Alessandro, who's here, is currently working with the ENVRI Hub team to look at integration of the ENVRI Hub into the new GEO infrastructure. The new GEO infrastructure is looking to EPOS for how we've successfully advanced our technical development. We're joining proposals with other partners, including the Horizon InfraDev calls that are coming up, but we're also involved in joint outreach activities. And I would urge you that if you're at the GEO meeting, if you're going to be at EGU, come and support EPOS, because there's a whole range of outreach activities, and we will be very visible at a number of activities going forward. So I've just given you a very quick overview of why, and it's to a certain extent, that's a personal perspective, why I think international collaboration is important for EPOS. But Federica is now going to talk about a survey that EPOS has conducted that I think will reinforce the importance of collaboration for EPOS. So Federica, it's all yours. You can have the scary thing back.
Thank you. Okay, so this I would like to shortly introduce this this survey we conducted in the framework of our collaboration with OSCOPE, Earth Science New Zealand, and EarthScope. And the idea here was to try and identify large cross-continent collaborations that were being carried out across our thematic communities, and in particular, the thematic communities we serve with our respective infrastructures, and assess the level of maturity they have to try and identify global collaboration use cases that we can start working on more specifically to improve our collaboration and go towards a more federated and integrated approach with our sister infrastructures. So the survey was addressed not to single researchers, but to large groups and consortia to try and look at something that were more stable and long-term than specific collaborations between scientists, because of course, otherwise the figures would be very much different. So we got 33 replies from this kind of actor, which we know it's not the full picture, but is already a good start. As you can see from the pie, there's a staggering lot of different scientific domains and topics involved in these collaborations. And I must say that unfortunately, or fortunately, because it means that you here in this room and your colleagues have done your homework and participated in the survey, right? Most of the replies come from the EU and in particular from the EPOS environment, let's say. So I think, and I'm talking here to Elisabetta and the colleagues at home, that we can do better to spread the word in the other infrastructures. But I think that the picture is nevertheless an interesting one for because it involves a lot of countries. You will see that there is quite a widespread geographical coverage already ongoing, with only the US and Australia being really outstanding compared to the rest. So this is a picture of the active and planned collaborations. Interestingly, most of the respondents listed more than one collaboration. So we can say that probably the consortia and the groups we were talking to have well-established channels for cross-continent collaboration. And you can see that almost half of these collaborations have been defined like mature or at least active. So this is not going on since yesterday, which is a good thing. And this is a picture of the geographical coverage. Of course, unsurprisingly, there is a lot of European countries there. But beside that, I think the interesting point is that there is no single world area where our community didn't arrive, with the exception of the obvious exception of the Arctic, but only because there is no one there to collaborate with that is actually based there. And you can see that there are a few key players in Europe and outside Europe that keep coming back. In particular, at the level of the countries, we have Italy, Spain, Greece, Czech Republic, France, Germany, and Switzerland leading the collaboration part. We have several actors from the Americas. The situation is a little bit more fragmented in Asia and Africa. If you are interested in learning more, here is the list of key institutional players that were identified and mentioned multiple times. I'm only going to say two things about this. The first one is that our sister research infrastructures were mentioned multiple times. So I feel like this is a sort of a confirmation that we went the right way when we started agreeing MOUs with them, because it seems they are the right people to talk to start this conversation. And the other thing is the global geodetic community seems to be probably the most well-equipped to go global, to be global already. Not the only one, of course. So this is an overview of the topics that were reported as the current collaboration topics. You will see that there is quite a broad range of this. To me, one of the most interesting things is that despite all this variety, we have 4 topics that cover almost half the scenario, and data collection and data integration are paramount in this, which is also shown when we look at the outputs of the collaborations. Because at the end of the day, what we see is that this global collaboration focus very much on the scientific part, less so on the technological and research data management side. But we will see in a while that awareness of this aspect is growing. So we tried to also assess the situation as it comes to openness and fairness. So trying to understand how the different letters in FAIR were addressed. Seems that F and A are more or less working partly there at least for the licensing part. Interoperability is probably the one that is less well developed. So this is something we can bring home and work on. But now this somewhat for the present picture. Now, if we look at the future, I think there are a few interesting findings from this survey. The first being that there is, despite the fact that there is clearly a well-established network of collaborations already, there is much interest in further expanding it. So our community is ready to go even further. And the word cloud can show you at a glance what this collaboration should be about. If you want a more numerical view of the topics for future collaboration, here it is. And here is the thing I wanted to point out, because despite the fact that the single more important part is still data collection and instrumentation, data harmonization and data integration and federated access have quite a large share of the pie, which to me is an important indication for actors such as EPOS and its sister infrastructures. Concerning the geographic reach, again, almost every place in the globe is there. Interestingly, the one that has grown more compared to the actual is Latin America. So we need to start conversations with this part of the world as well. And this is a more visible way to show the same thing. But also you will see that if we sum up all the Asia or all the Africa, we get important figures as well. Now for the barriers, Ellen spoke about some of them before. So that's the picture of what our respondents had in mind. Of course, funding and resources in other forms like staffing and time are unsurprisingly the leading points. But interestingly enough, partner discovery and alignment of priorities, which are more strategic or soft aspects, are also very present. And I think while we cannot do much for the funding part, unless advocating for more stable funds, we can do a lot for this softer and more strategic part. And also it is worth noticing that most of the respondents indicated not just one, but multiple factors as barriers. So we need a systemic approach to address this. But we also asked how we can help. And I think that there are a few interesting insights there. Funding intel, so scouting activities for funding and the programs that can help furthering the collaboration is something we can think about. But also, if you look at the first two rows there, communities of practice and training are just two sides of the same coin, competencies. And I think that here we can do really a lot to help. These are, I promise this is my last slide. we tried to have them listing expected benefits of this extended collaboration. And one important point, and the top themes for collaboration. And I think that one thing is clearly outstanding here is the importance of community building, which being at an event that brings together the community seems very much to the point. So apparently we are doing well here. And so the EPOS Days took a lot of work to put together by many people. But it seems we are doing exactly what the community needs right now. And thank you.
Thank you, Alan. Thank you, Federica. The next talk is relevant for one of the tasks of WP5, which is very close to my heart, and also judging from the program, very close to EPOS's heart, which is collaboration with Africa. The presenters are Oussama Arab and Mohamed Master, and the title is Strengthening Morocco's Integration into AIDA. AIDA is the data collecting organization for Orpheus, the data nodes. So who is presenting? Oussama Arab, right? The floor is yours. Thank you.
So, hello everyone. So, I'm Professor Oussama Arab, and with me, my colleague, Professor Mohamed Master. So, we are very honored and glad to be here in front of all of you. And we are here to present our perspective towards strengthening Morocco's integration to data archiving into EPOS, toward the institutional collaboration for advanced seismic geodetic monitoring, and through the National Observatory of Natural Hazards. So to do so, let's start with a brief introduction about Scientific Institute of Rabat, which is the institution we came from. It's from Mohammed V University, Rabat, Morocco. So it's which is the first institution in Morocco for seismic research, which plays a crucial role in collecting data and seismic research, which based on three main topics: Earth, botanics, and zoology. We have also 5 departments. The first one is geology, the second one is geophysics, the third is botanical and ecological sciences, the fourth one is zoology and environmental studies, and the last one is geomorphology and geomatics department. So the current status of ES Rabat seismic network is mainly based on 6 observatories. From north to south, we have the Observatory of Al Hoceima, also the Scientific Institute Observatory, and Ifran Observatory, which is near to, and the biggest near city is Meknes or Fez. We have also Observatory of Averroes, which is near to Barshid city, and the biggest near city is Casablanca. We have also Tiwin Station or Tiwin Observatory, which is near to Ouarzazate, and Ain Chorkoz, which is in the region of Assazag, Moroccan Sahara. So the first station or observatory was constructed in 1913 in Barshid. So the first seismic station was installed in 1937. And the last updated seismometer was installed in 2006 with a broadband seismic station. And as for Ifran, it was constructed in 1964 in the Middle Atlas domain, with the last seismic station was installed in 2007 with the same seismic station of Barshid. We have also the observatory of Tiwin, as already explained, It is far from Ouarzazate of about 40 kilometers and constructed in 1971. And the last updated seismic broadband station was implemented in 2008. As for Assazak was constructed in 1991 in the western Anti-Atlas and Moroccan Sahara domain with a very broadband seismic station in 2007 that was implemented. And also we have the Observatory of Rabat, and the Scientific Institute was constructed in 1920 instead of 13. I've made a mistake. And also the first seismic station was implemented in 1966 with the last upgrade was in 2005 with broadband seismic station. As for Al Hoceima or Ben Hadeifa Observatory, it was the last that's been constructed in 2020, and the last seismic broadband station was installed in 2024. So we have also the new seismic network of Al Hoceima region, which is located in the Rif region in the north of Morocco. We are intended to implement 6 other stations that surround Ben Hadeifa station. And we have 2 other options. We already purchased one broadband seismic station that we are looking to implement in Larash city or in the region of Larash city. And also we are looking to switch the seismometer from wind turquoise to Al Haus region, since, as you know, we had a devastated earthquake in 2023, and we have a bad coverage in Al Haus region. As for the Western Mediterranean Seismic Network, which was operating since 1996 with 20 stations, and currently the only Moroccan Western Mediterranean station openly available in Ada, in the data archive that's linked to Orpheus and EPOS, via GFZ, Germany, RT-WIN and Averroes from Barshid and Ouarzazate. So this Western Mediterranean network was a consortium including San Fernando, Real Observatorio de la Armada, ROA, and Universidad Complutense de Madrid, Helmholtz Zentrum, Geoforschung Zentrum GFZ from Germany, and Universidad de Évora, Portugal, and last Scientific Institute of Rabat, Morocco. So currently the university is present in 6 regions through its existing observatory, as already I explained in the previous slides, and we are intending to add 3 additional observatories. 2 additional observatories were already planned for Larash and Tétouan cities, with another one in the province of Khmisset. We also have a geodetic network that need to be improved. We have 7 stations that was put together with our colleagues in Europe. We have 2 existing stations, 3 other stations in 3 other universities that we have no info, and 2 other stations in Barshid and Agadir that need preparation. So this is kind of challenges that we are facing in our seismic network. We have some equipment obsolescence. We have coverage gaps, as already explained, especially in the region of Al Hoceima or the Rif region, which is considered as a active seismotectonic area, and also Al Haus region since 2023 and before, of course. With the devastated earthquake that's happened. So also we have a problem with the data integration, and it is due to equipment that need to be upgraded. So the future plans for the Scientific Institute of Rabat is the expansion plan for 2025 and 2029. And we have 2 objectives or 2 aims or 2 goals. The first is seismic hazard assessment through our seismic network. And the second one is earthquake early warning system. And I will let with Professor Mohammed Master to bring or to explain what other alternative collaboration that could be durable and secure to manage this collaboration with Ada.
Thank you very much, Oussama. Hi, everyone.
and thanks to the organizers. As Usama just said, we've been facing many challenges and many issues. And to address this, Morocco has taken many measures during the last few years to improve all of this. And as you can say, the main important measures are listed in here, and we've launched, or we've started by the creation of the CVC. The CVC is the equivalent of the FEMA. It's like a national agency for monitoring, supporting all emergencies related to natural disasters or man-made crisis. We do also, we did created the FLCN, which is a specified fund which can support financially all action related to prevention and response. Then we extended the coverage of this fund by financing post-damage and risk reduction actions in alignment with the Sunday framework. But the two most important actions that have been taken the last few years were the creation or the launch of a national policy. And we're going to see later how important this national policy is to our cooperation with all our colleagues across Europe to improve the integration of Morocco in the AIDA initiative. And we had also the creation of a special direction within the Ministry of Interior, which has the responsibility to manage and to coordinate all the involved stakeholders. As I said, here is the first page of the national policy, and this national policy consists of 5 important pillars, and which are the strengthening of the governance, improving the knowledge, preventing natural hazard. As you know, investing $1 in prevention avoid us a cost of $7 in recovery. But the most important pillar of this action is the promotion of scientific research, international cooperation, and capacity building, which is in alignment with the objectives of AIDA initiative. And what interests us the most in this pillar or in this action can be described, as you can see, the promotion of the scientific research, promotion of international cooperation, and the capacity building. We do have other programs, but the most important thing is that these programs are part of the national policy, and the national policy has a specific fund which can financially support our initiative within the AIDA framework. And this will allow us to take our collaboration and our cooperation into another level. As my colleague mentioned before, this will allow us to improve the data exchange, the capacity building, and the scientific research part also. These are also programs that are intended to be improved by the national policy. these programs are intended also to cover the risk assessment part, definition of the standards, and the data processing and the data sharing, which is an important part of this project. So in few words, as a perspective and conclusion, Morocco is trying to strengthen its integration into the ADA initiative to ensure an open access and interoperability of seismic data, enhancing the national monitoring capacity through the National Observatory of Natural Hazard, also the integration of additional Morocco station into ADA, supporting the development of the network through national funding mechanism, and also expanding our cooperation. And one last sentence, we do have the opportunity to get funds from our national policy. So let's talk about it to take our cooperation to another level, and thank you.
Thank you very much for that. Oh, okay.
Sure. Thank you for your presentation. Very informative. I have a question. Do you have any plan within this program to also increase sharing of sea-level data through the UNESCO platform, which is also distributing the data through EPOS? Because sea-level data would be important for filling the gap for tsunami warning.
I think that my colleague Usama is more qualified than me to answer this question.
Can you please repeat your question? Sorry, I didn't hear you.
If in this program there is a plan for increasing the sharing of sea-level data through UNESCO and for the tsunami warning system.
Okay, in the principle, yes. I think the national strategy has the intention to share data with all international collaborators, but we just need to transfer or give the information to responsibles there, and everything would be possible, of course.
Within the national policy, 5 specific hazards are covered. We started with 5 specific hazards. So the seismological hazards, landslide, tsunami, drought, and floods. And yes, in principle, yes, there is a plan of covering and for the exchange of data related to this hazard also.
Thank you very much.
Yeah.
Sorry, a question and a comment. The question is, have you already contacted some AIDA nodes for data distribution you have in mind? Maybe...
You're talking about this with Angelo.
Angelo, yes. Indeed, if I understand well your question, we already collaborating with Angelo in the seismic field, and we are willing to solve some administrative issues in Morocco. So as we to integrate other kind of data, such as geodetic data, as we already have a geodetic network also, and why not other kind of data?
And as a comment, I will say that what have you shown, for instance, in the framework of early warning systems, you have seen that there are also TCSs working on this, near fault observatories and tsunami, for instance. And indeed, you have plans for a kind of rising PhD schools dedicated to this. So this might be opportunities to share best practice with enforcing collaboration or even bilateral agreements that EPOS could sustain in this line.
Thank you.
Yeah, and this is actually my comment. So I thank you, Stefano and Gaetano, for bringing the point, because yeah, my point is exactly this. So you are now starting this collaboration with AIDA and sharing data in AIDA, and so EPOS. But yeah, please consider that there are other communities in EPOS, the tsunami, the near fault observatories, the GNSS community, others that might be very much interested in collaborating with you. And so if you see that having a formal I mean, a memorandum of understanding, for example, with EPOS as a way to actually facilitate this kind of collaboration, yeah, we can discuss about that. And about and also please consider, maybe you can ask Federica for more details after that. We are also organizing summer school for students, and the next one will pretty much focusing on data management, for example, so that you might have students that are interested in participating in this kind of summer school. So just to say that there are a lot of possibilities for collaborating.
Yes, of course. And I just want to tell you that we are always open to another collaboration. But first, as we already have the experience with seismology and that, we want first to secure like a durable and secure collaborations first, and then we go further step by step. Okay, thank you very much.
Okay, thank you very much. Bear in mind that we will have 45 minutes for discussion at the end of the session, but of course, if you have any pressing questions or comments, we can also do it that way. So the next talk is entitled EPOS Collaboration with the Global Earthquake Model and the Global Tsunami Model, Potential Services and Licensing Models for both Research and Commercial Use. And the speakers are Finn Lovold and Ellen Crowley. Finn.
Thank you, Al. Yeah. Okay. I will do the first part of the presentation, and Helen will take the second. So we have, of course, before presented both Global Tsunami Model and GEM here before. So we decided this time to have a topic really on the service provision, but also discuss a little bit on the licensing models and diverse sets of users. We added also the term public here in terms of also research and commercial use that may necessitate different models to license and make the model available. First, a few words about the Global Tsunami Model. And this was presented on EPOS Days last year, so I'm not going to repeat too much of that, but maybe say that it's a bottom-up initiative from the science community that has been, let's say, evolving over 10 to 12 years. It's been really something that came up during the so-called global risk model that the UNDRR developed over almost a decade, up until 2015. And since then, we have been a bottom-up network of scientists that actually developed this association that was formed last August. So since the last EPOS Days, we are now a formal organization. We can act as a formal organization. And we have been originating in Europe through cost networks, but we are now trying to diversify beyond Europe, so we are really a global organization. I think this is one of the assets for EPOS as well, that we can diversify beyond Europe and attract also users that are truly global. We are right now a not-for-profit organization, so-called EV, organized from Germany. And we do the membership management. We have some units and working groups. And we have around, I would say, 30 to 40 institutions that have signed letters of interest from before that has supported it. So that really shows the breadth of organizations that stand behind from the past. And we are continuing now to develop the organization. What we are doing right now is to develop some initial products and also have the possibility to conduct projects. As you have probably seen from some of the presentations the other days, tsunamis may be a little different from many other services, as we are quite tailored on numerical models. And right now, we try to focus on a few of them to consolidate our key services. And they are really encompassed around probabilistic tsunami hazard analysis models. And we are, as I'm going to show in the next slides, we are going to do a new global model. We see one of the previous ones here from 2018 that was coming out of this network while we were operating more informally and formed by the aftermath of the global risk model. We are also trying to make these models scalable, so we can go from really informative, high-grained global models to local, high-resolution inundation models that can be used for risk analysis. And this is, of course, very important to be able to use these products for actual hazard analysis, mapping, early warning, etc., all these type of things that end users need. We can also broker our expertise from the members that are presently forming the association, but also facilitate consultancy and do training and model evaluation. So we also want to be an organization that train scientists and others to learn our models and procedures and provide standards. So what we are trying to make right now is a workflow that is also scalable from PTHA, probabilistic tsunami hazard analysis. We are using workflows and developing workflows that can utilize HPC, as we often need to run massive amounts of simulations. And we are with GEM, we are trying to be interoperable, to work together, so we can provide products that are more multi-hazard. That means that when you do a hazard analysis, you would have the same type of source information propagating through your probabilistic model. And therefore, we are doing this also through OpenQuake and generating ruptures and scenarios there. The global to local scalability was mentioned, and also the possibility to actually do risk analysis and loss modeling that to quantify losses from these probabilistic scenarios. The global hazard model is our key activity at the moment, I would say, from a technical point of view. And what we are trying to do here is to move beyond the state of the art that was produced in 2018, with taking into account several more modern achievements in terms of tsunami science that we know affects the hazard. Probably the most important aspects of this might be the heterogeneous rupture that we know will be biased if you don't have it. We also have important things such as interaction with sea level rise, depth-dependent subduction properties. Very important also, I think you could see from here, the pink points showing the new small island development states being added to the hazard, which is super important, especially for low-lying land, etc. And we also do introduce multi-expert protocols that allow us to do better uncertainty treatment and treat all these really subjective terms that propagates. Also, we are developing workflows that may enable people to take their own models, their local bathymetries and topographies that we need on high resolution, and slot into the scenario database we have from the global model or other models, and run local high-resolution risk models or hazard models. So what is the potential benefit for EPOS? I think one thing we see is that from our TCS community, there's a large degree of overlap. We do leverage a lot of the products here. We use, for instance, tsunami high sea and the amplification factors, as was shown yesterday. There's also several other services that are brought into practical use. The global perspective is important because we will introduce more and more global participants from the science side, but also we might attract other types of users that is not normally a part of the EPOS community, such as the civil protection and the tsunami service providers, but potentially also private users, such as insurance sectors, engineers, and planners. But to do this, we need also a long-term sustainable funding mechanism. And that was placed into probably the licensing and these type of things. Remember that GTM is still a young organization. We are still working out these type of things, but we foresee that we are going to license products openly for the public good and research, but we may need a diverse set of licensing models for commercial use and other types of users. Helen is going to show more details about this in the next part of this talk. But I'm going to say also that in terms of bridging the gap to society, we are going to be an operational organization that do projects, but also we will strongly advocate being a player that brings to the table guidelines and standards. And I'll point to this recent book that has been published on probabilistic tsunami hazard and risk analysis that just came out a few weeks ago. That is an example of how this bottom-up initiative works, and this is open access, so you can download the book from the link I provide here. So with this, I think I'll just say that GTM is formable and invites contributions, and hand over to Helen.
Thanks, Finn. So let me tell you a little bit more about GEM, the Global Earthquake Model, in case you're not familiar with us. But we are now 17 years old. So we were founded in 2009. We are a non-profit organization. We're also recognized as a NGO by the UN. And we're governed as a public-private partnership. So we have a governing board formed of public partners and private partners. And so on the public side, we have organizations from many countries. They could be civil protection departments, geological surveys. And on the private side, we have lots of private organizations, especially insurance, reinsurance, and engineering organizations. So we're based in Italy, in Pavia, and that's where the GEM Secretariat is. So you see on the figure on the right there, you've got the GEM Governing Board, this public-private partnership, and then the GEM Secretariat. And we're about 30 or so staff members at the GEM Secretariat. We also have lots of PhD students. We're working with about 10 at the moment. So we do lots of research and development. And that's where most of the GEM work is sort of led out of the GEM Secretariat. And so our mission over the past 17 years has really been to develop transparent and open resources for seismic hazard and risk assessment for anywhere in the world. And we've done that through collaboration with hundreds of different organizations, putting together this global model of seismic hazard and risk and releasing tools and software and data. So we've been connected somewhat, maybe indirectly in the past with EPOS. So we've been supporting for many years EPOS seismology and EFAIR, the European Facilities for Earthquake Hazard and Risk, which is one of the pillars of EPOS seismology, especially with our open source software. So I mentioned yesterday the OpenQuake engine, open source software for hazard and risk assessment. So that's been used in the European Seismic Hazard Model, the European Seismic Risk Model, and we've been also supporting in the development of those models as well. More recently, we've become directly into the EPOS On project. I presented yesterday some of the works that we've been doing with rapid post-event impact assessment, and also we're supporting the task on services and products for seismic risk. And I think Ruri presented on Monday how we are one of the first service providers within the potential candidate TCS built environment data. So that was the embodied carbon. Because we've been looking at the built environment now for many, many years as we build up this global model of seismic risk, we've been looking at different buildings in different countries, and we've started to look also at the embodied carbon of those buildings. So we have many products. If you go to our website, globalquakemodel.org, and you can go to the page products, you can find all of the different products that we've developed over the years, similar to many of the products that GTM is planning. So we have our global seismic hazard maps, we have the global seismic risk maps, we have the engine I've mentioned, but as input to those, you have the exposure models, so the characteristics of buildings in different countries, the vulnerability, different vulnerability models for different building types, and we also have a number of risk profiles for different countries. And many of those are also available on our GitHub. So we open release them on the GEM GitHub page, or we also have a community page on Zenodo, where we release many products in order to make them more fair, assigning DOIs and so on. I wanted to talk a little bit more, as Finn said, about licensing, just to share our experiences with you, with EPOS, just to see if this could be something that could be of use or consideration for EPOS as it thinks about how its products are used more, especially by the private industry, because we've been working many years with our products being used by engineering organizations and insurance and reinsurance. And so from the beginning, we've decided to release the products in different mechanisms. So many products, as I showed you in the slide before, you can go to the website. We release them typically with a Creative Commons by essay or by non-commercial essay, and I'll explain all of those in the next slide. But those models can be openly downloaded and by anyone without asking any information about the people from the website or from GitHub and so on. And for the software, we're using the AGPL open license. We also have other data. We've been working in different projects over the years. We have other models which you can't necessarily find and download from the website, but you can find information about them and you can click a button and request that data. So we have for every single product, we have a license request. Maybe you need to use the data under a different license to the one that it's originally released under. So you can contact us and we will always make that data freely available if the final use case is a public good or research use case. So then we freely provide that data and after the requests, once we've understood a little bit better what the needs are. We also can provide the data if someone wants to use it commercially. So perhaps that data is available out there, but we've put the non-commercial clause on the license. And so we receive requests to use that data commercially, and then we can provide a license for using it commercially. But as I mentioned before, we always freely make everything available without any costs if it's for public good or research purposes. So just to explain those different attribution, the different clauses in the CC licenses that we use by attribution. So we want to be recognized for being the owners and having the IP of those products. Non-commercial on some products when we do want to restrict the commercial use. And share alike, we add that because we want to understand, where those products are going to go. We want to make sure those products remain open. It requires that the same license needs to be added to the derived products. So it allows us sort of enforce openness, and you can't then put that product into a closed proprietary format without at least informing us and getting permission from us first. So in some ways, it's all a little bit about having control. We're not control freaks, but I think we do want to understand where those products are being used, because these really are products that are being used, as I mentioned before, by engineering companies, by insurance and reinsurance companies. So it allows people to contact us to say what they want to do with the data. And sometimes we can point them to data or products that we think are better for their use case. But it allows us to go through that process of understanding better where our products are being used. So just to give you some of our experience of this, so we released in 2023 our global seismic hazard map on the website, openly downloadable with a CC BY NCSA license. We did the same with exposure models for the whole world, same license on GitHub. And we have received many requests since then to use those products commercially. And now, 2 years later, we have about 10% of our budget is coming from us selling commercial licenses for those products. But we make sure that we reinvest that into GEM, into the science, into developing those products, and especially in supporting the Global South. So happy to answer any questions you have on that, and I will leave it there. Thank you.
I don't know if there are any pressing questions.
Yeah, Helen. No, more than a question is asking for support, because I mean, as you know, in EPOS, all the data, all the services are free, but we need to learn how to interact with private sector. I think this is something we still don't know how to do very, very well. So maybe this collaboration with GEM, beside everything you said and all the other, which is okay, that's fine. Maybe this collaboration with GEM, we can also support EPOS to learn how to better interact with the private sector, because you have a lot of experience. So I don't know exactly now how to do it, but
we've started with the GTM.
Yeah,
so
exactly.
We've started, and so this is a good start, and
Yeah.
then we can extend.
Yeah, so I think that also this exchange of experience, it's very important in this kind of collaboration between you and EPOS. I'm very glad about this.
Thank you. Really.
Do you have another question in the
Yeah.
Hi, Helen. Kirsten Elger from GFZ. I would like to raise caution of using the share-like license for data, because you explained that it guarantees that the data remain open, which is the argument I would use for software licenses and for some like GPL things. But looking at the usage of data, and that most of the data are released without a share-like, means that if you put a share-alike license, you restrict the usage of these data, because once merged with other more free products, you restrict the freedom, like the free reuse of these others. And obviously your products are potentially very heavily merged with other products. And I just wanted to start a discussion on, do you really want to, are you aware of these restrictions?
Yes.
And I'm not discussing about non-commercial. I understand with the private sector, that's perfectly fine. But the share-alike is really, really a big barrier, and absolutely in contrast to open science.
And we know that there's a big question about us putting share-alike on the products. I think it's not data. I don't think you can say what we release is data. It's really products. It's models. You know, there's a lot of combination of data sources of intellectual property in there. So I don't know how much they need to be combined with others, but as I mentioned, you can always request for us to allow you to use it without the share-alike, and we will do that. But as a first aspect, as I say, we're not releasing. It's not data on recordings from stations, or these are real products that are being used. So if we didn't put the share-alike, those products, even if we put the non-commercial, doesn't quite ensure that those products won't be put into proprietary platforms and software.
Yeah, well, but I didn't speak about data, because data is not allowed to get a license because you don't have intellectual property rights. I'm referring to products. I see your point, but I have many discussions on these kind of licenses, and it is really, I don't know, if we speak about open science, what you can do is you can restrict. And we have possible examples for how do you ensure, like, non-commercial. If people can download the data, how can you prove that this was not a company? So this would mean you have to restrict the free access, and you have to say, let me know why you want it. But share-alike is really not free data, and I really want to bring this point very strongly.
Free by open, you mean?
Open, yeah, open, yeah.
Maybe we can
let's
that
continue.
discussion in the interactive discussion later in the morning. So thank you very much, Alan. Thank you, Finn. And the next talk is called Report from the Argonaut Network, Collaboration Perspectives Among Global Near-Fault Observatory Infrastructures. And it's presented by the Argonaut team. And
thank you. Yeah, I'm Lauro Chiaraluce from the Near Fault Observatory community. So I want to briefly summarize the 2 days meeting that we had right before the onset of the EPOS Days here in Cagliari, and about this initiative that within the EPOS project is related to the cooperation with the more than international, with the global, let's say, initiatives, because we try to deal with non-European institutions and agencies. But I wanted just to start with this figure because, because I want to emphasize that during the meeting we had people from Spain proposing a near-fault observatory in southern Spain, dealing with the multidisciplinary monitoring of the Alhama de Murcia fault. And as has been told by Alexandro on the first day, they asked to become observer in the community. In 2025, we already had 2 other new observatories, Kars from Slovenia and Nitro from northeast of Italy. So we are growing. We are very proud of that, and I wanted just to say it again. So Argonaut is just the acronym for this idea that we have to go towards a new generation of observatories near faults, and we wanted to discuss this idea about the future together with the other institutions outside Europe, as I said. And so we have been in contact with the colleagues in Japan, USA, China, and New Zealand. Unfortunately, people from China and New Zealand couldn't make it in person. But still, the discussion was very, very interesting. And after me, and David and Hiroshika will give you taste about that from their perspective from the US and Japan. But I want to tell you that we wanted to see if in these sides, outside Europe, in this side of the world, there were other initiatives comparable to the Near Fault Observatory. So that, wanted to embrace this holistic approach in Earth system monitoring, trying to integrate different data, multidisciplinary data collected near faults, and to find a way to transform these new ideas and new findings about earthquake physics and transform them in services and then ideally in tools for societal safety. So we discussed ideas and common challenges about those aspects, and we share, just scratch the surface. We want to share common new technologies development and strategies on how to do that. And we would like to write a white paper about this also in the framework of a European project run by the NFO community led by the Greek colleagues. And we discussed the further possibility to create new services and data. That is one of the key goals of EPOS and the EPOS On project. So, but while doing this discussion, we realized that we had different approaches in the global landscape, let's say, in just having also a common understanding of near fault observatory. So in Japan, for example, we had we call it the challenge of ubiquitous faults, because there are active faults everywhere. So where to install a near fault observatories, and but the point was possibly to find specific spots where really integrate, for example, geochemical data or new techniques like DAS and so on, with this extraordinary seismic and geodetic data that they have, to demonstrate somehow how this approach in science can really give a benefit to the community. And so that's the way to go probably in that area. While in the US, there's a different the momentum is on different topics, aspects, and they're working a lot on the new infrastructure building for monitoring subduction zones, and they focused a lot on pushing on this, what they say, ARC, analysis ready cloud optimized. The idea there is really to put multidisciplinary data together, all the data in the same place, and bring computer scientists and computing capability really into the game for the machine learning and the AI and so on. They also have new ideas that I think David will introduce about digital twins that will include also literature and codes also for real time and computation. But their idea of near fault observatories could be just some kind of focus of the infrastructure, of larger infrastructure in specific places like the NOTA. So next steps, international networking. This is where we will keep working. So launching possibly together within the EPOS framework a series of webinars to increase, to foster that direct science exchange and collaboration between other continents, and the capacity building. Of course, we want to create the opportunity for training networks and visiting between scientists from these different environments, and possibly also PhD would be a great thing to share, and then work on this common technology on standards and generating standards for the new instruments that we are preparing in different fields. So to have a common approach on this that doesn't change across the borders when dealing with different instruments doing the same thing, and so metadata curation and so on. So that's all for me, and I leave the floor to David from EarthScope, and then to Professor Hiroshika from Japan. Okay.
My name is David Menson, and I'm the Vice President of EarthScope and faculty at University of Colorado Boulder. And I'm just going to give you guys an update. It's going to be hard to look down here instead of up there. I'm not used to that. On our relationship, EarthScope and EPOS. So for those of you, I'm going to give a little history of Earthscope quick. For those of you who don't know, Earthscope is the main body in the United States that represents, or historically has represents the seismological community and geodesy community. These are all undercounted because we don't really have a good way of doing it, but we have close to 500,000 citations, 14,000 unique authors. You can read down the list here, 31,000 unique data sets, and 439 experiments. So these are the what used to be called SAGE and GAGE or IRIS and UNAVCO from the period of 2018 to 2025. So Earthscope, I think a lot of people have collaborated with IRIS and UNAVCO. So from 1984 to 2023, they were two separate institutions. And unfortunately, there was a giant project called Earthscope, which causes some confusion, where we built extensive infrastructure in North America. We merged in 2023 to become the Earthscope Consortium. And in 2025, just last year, everything was recompeted. It was potentially unfortunate timing to recompete in 2025, but 2 weeks before we were going to run out of money, we were notified that the National Geophysical Facility was funded in full for the next 5 years. So things look good right now for the NGF. The other big things that are different about the NGF for our collaborations are now, previously international collaborations were something we did as a part of our mission. Now it's a specific goal of our mission to have international collaborations. And another overlap with EPOS is the near surface geophysics community is also now under the National Geophysical Facility umbrella. So that brings in a whole new slew of data types like geochemistry under the NGF umbrella in the United States. So the National Geophysics Facility, it took the ideas of IRIS and UNAVCO and large facilities and has pushed the idea of integrated geophysics in the U.S., mostly built around the open data model. So you can see here all the different data types that we, or a subset of all the data types that we take in. We have these ideas now, and these are built out actually in a lot of ways where we have modernized our networks, where we push edge computing out to the sites. Our data is now all in the cloud. We don't have a physical footprint anymore. We have a footprint of roughly 4 to 5 petabytes, but it's all in the cloud, adjacent to HPC. And of course, now we were primarily research institutions before, or research support institutions. Now we actually directly and operationally support earthquake early warning in the United States, tsunami warning in the United States, other hazard projects in an operational way as opposed to just a research way. And of course, we continue to have the main mission of science, observation, and discovery. Like Laura was saying, we are embarking on trying to federate our data within the U.S. and with our international collaborators. This is a good example of one of the things that we've been funded to do. So NODA, our GNSS network that we operate, is roughly, at this point, around 1,200 stations. But since GNSS has a commercial driver, we're aware of close to 8,000 other stations that exist in the U.S. So we have been funded to go purchase or consume or adopt all these data. Most of it's open as part of like state cadastral networks and whatnot, and the data for them only has value in real time, and then they typically make it open later. So we expect over the next 5 years in this one area to, increase our data holdings by an order of magnitude. Like I said, we've moved all of our data into the cloud, which has enabled us to, we believe that's one area where there'll be transformative science without a major investment in infrastructure. And this is one example that we did earlier this year. where we were able to take a subset of our seismic data, roughly 1.4 petabytes, and run PhaseNet, phase picking, and then cross correlations to pick out earthquakes. So the output was something 4.3 billion picks, and a new catalog of this number has actually been gone up to close to 100 million at this point. The big point about this was it only took a day to do this, or a little more than a day to run this experiment. So these are the kind of capabilities that we're pushing on, because we have lots of data that's more or less inaccessible because it's either too voluminous or the pipes to get it are too small. So in our case, like this data was previously housed at IRIS, it would have taken close to 9 months to get the data out of the data center just to move it. And then just a quick focus on our partnerships. We have signed a MOU with EPOS, Oscope, and Earth Sciences New Zealand. This was signed at the end of 2024. There was not a lot of effort in 2025 because of the US funding ambiguities. But since October of 2025, we've pushed hard on trying to complete our work package that I'll show you here in a few minutes. There's incredible alignment between all these organizations, between the TCS is plotted up here. Earthscope isn't quite built like EPOS, but basically we overlap in almost every single TCS, as well as with Oscope. We've had already a lot of interaction with seismology, GNSS, and the NFO, and we'd like to expand that to the rest of the TCSs. So our 2026 work plan, mapping our collaboration, which we're in the process of doing. We're supposed to establish a steering committee to guide this collaboration, which has not started yet. We were supposed to organize activities of common interest for EPOS this days of this one, which we did not really do. Again, we started late because of the funding ambiguities in the US. And we will be organizing activities at EGU and AGU. And we have been supporting in-person meetings, which I'm going to go over quick. We've already had 3, like Laura said. So in February, there was a workshop jointly between IGS, EPOS, and Earthscope and Oscope and GNSS Science to develop new storage formats for GNSS data. Like I was pointing out before, our biggest hurdles these days are just getting people access to the data. We have well over 100 million RINEX files, which are inaccessible in their current format. The following week after that, there was a workshop for data containers for large data sets, which included seismology and DAS. Both of these workshops were successful. And then this last weekend, there was the Argonaut meeting, which we hopefully will push forward, like Laura said, on near fault observatories. The only major near fault observatory in process, or at least in process of being funded in the US, is the SC4D, which covers the Cascadia, Chile, and Alaska. And of course, we have history of supporting Taboo here and the Marbra in the EPOS framework for near fault observatories. And that's it for me. Any questions are later? Okay.
Okay, good afternoon. Good morning, everyone. I'm Hiroshika Sumino, working in University of Tokyo, Japan. So now I'd like to talk about the current state of the monitoring in Japan, about the seismological and the geodetic data, and also about the recent advancement of our geochemical monitoring. So in Japan, we have, we already have a very strong the monitoring system about the seismological and geodetic data, which you can see here. This is this high net. Oops, not high net. Yes. Yeah. We don't see it. Okay. So this is a high net, inland seismological net observation network, and also this is SNet and SNet here, and sorry, SNet here, and the DUNet and the NNet here of the seismological monitoring system. And also we have a very lot of the observations site for the geodetic monitoring, because we have a lot of the fear about the earthquake, not only for the inland earthquakes by the active fault, but also the megathrust earthquake along the trench. So in terms of that, all of these are unified by JMA, Japan Meteorological Agency. Actually, most of the observation site is run by other agencies like NOAED or the GSI, but all the data are unified to the JMA for the real-time response and rapid modeling. So in this figure, in this slide, I showed some example of the real-time response. One is a RIGARD, real-time journey analysis system for rapid deformation, which provides real-time finite models for magnitude greater than earthquakes using the GNSS data. And the other is SDDS, Seismic Ground Disaster Assessment System, which provides rapid run-side liquefaction assessment. So we have an example for the Noto Peninsula earthquake in 2024, which has a magnitude 7.6. So right after, actually the 6 seconds after the first main shock, the first earthquake early warning was announced by JMA. And it is modified and improved second by second. And when we have this earthquake, I was in Tokyo, but also I had early warning from the system about the level 3 shaking, even in Tokyo. And 4 minutes after, RIGARD successfully estimated a fault model, which is very effective to aid immediate initial response and also particularly the tsunami predictions. And 8 minutes after, the SDTS completed map of the potential ground hazard, like the probability of the landslide here, and which is very yes. And then all the data is delivered to the relevant agencies, like local government, or of course the main government of Japan, and also the local government. So these are very effectively working in Japan right now. But on the other hand, in regard of the near fault observatory, like the inland, to monitor the inland earthquake, as Raul said, that it is very difficult. This figure shows the active fault that this map is from the active fault database by GSJ, Geological Survey of Japan, which shows the active fault zone in red, and the other fault in black. And also the color map shows the probability of the big earthquake within 30 years. And these are the relatively big major inland earthquake which happened during the past 30 years. So as you can see here, we have a lot of the inland big earthquakes. So as Raul said, it's difficult to establish the near fault observatory, because we don't know which is important and also which caused the next big disaster in the near future. But even though, if we have several series of the swarm and relatively big earthquakes, we can do the not permanent but mobile near fault observatories, or not the fault observatory at a certain point, but like a mobile measurement or analysis. So I'd like to talk about our research about the Noto Peninsula earthquake. So as I said, in Noto Peninsula, we had a very big earthquake here, 2024, magnitude 7.6 here. But before that, this region is known as the kind of the nest of the earthquake. So in 1993 and 2007, we had relatively big ones. And also from 2018, the earthquake storm started and intensified in 2020. So since then, we went there to collect some samples to carry out the geochemical monitoring. Because as I said, the seismological and geodetic observations are already carried out, and so we have a lot of databases. And in terms of the data availability for the public, all the data by HiNet or other nets and also GeoNet are open to the public, so you can download, you can use the data for your own research. That's the reason why we have a lot of the very good seismic tomography everywhere in Japan. And this is very big advantage to carry out the geochemical monitoring as well. So this is a result of our helium isotope pressure analysis for the hot spring and the cold spring gases in Noto Peninsula. And this is a little bit messy, but only one thing I want to emphasize is that based on the helium isotope pressure, we can develop we can know how much the helium from the mantle and how much helium is coming in the crust. And as you can see here, we see the relatively big contribution from helium from mantle here and here. So we should have any special reason for this. And also there are several, some small areas with a relatively high mantle contribution, but this is associated with active fault. So when we compare with the helium isotope result with the seismic tomography, as I said, we can have a very good network to develop this kind of the seismic tomography. And here we have the high helium contribution site from mantle, and this is coincident with the distribution of the fluid, which is inferred from seismic tomography, S-wave velocity anomaly by the seismic tomography. And also it is supported by the magnetometric data like this. So we can say that some kind of fluid is coming up from the mantle. And also here we have a lot of the epicenters of the swarm and also big earthquakes, which means that the earthquakes and swarms and big earthquakes are triggered by the ascent of deep derived fluid. And also when we are looking at the time series of the helium isotope ratio, we can see this kind of the helium isotope variation in these two regions where we observe the relatively high mantle contribution. And as you can see here, the helium isotope ratio of these two sites decrease with time after the studying of the intensified swarm. And before the main shock of the in the 2024, it reached to the bottom and then gradually come back. And some of my colleagues, Professor Kagoshima-san and Sano-san in the other universities, conclude that these are the result of the release of cluster-derived helium because of the strain increase to make a lot of the rupture in the aquifer rocks to release the more helium fall, resulting in the lower helium isotope ratio. So this is kind of the precursor signal of the main shock, but we're not for sure because this is just one example in Japan. So we need to carry out this, continue this kind of work in Japan, everywhere in Japan. But the difficulty with this kind of the geochemical monitoring is that we need to collect a sample, and also then we need to take back into the sample to back to the laboratory, and also we need to use this kind of the relatively big instrument to precisely determine the helium isotope ratio. So it is not always easy. And also when we think about the distribution or the distribution of the active fault in Japan, as I showed before, it is almost impossible to monitor all the active fault. So now we are developing a new method which uses a relatively small mass spectrometer. It's 48 kilograms, which is, we could say portable, but it's not portable by myself. But anyway, it's small enough to carry with a car. And there, by using this, we can continuously measure the helium isotope ratio. But it is now still ongoing project, so it's now under development. So we have a lot of the problem, but the near future, we hope this can be used to monitor the active fault. So this is a summary of my talk. Although we have very good geophysical, I mean that's the seismological and geological monitoring system, which is already intensively carried out in Japan. Ubiquitousness of the fault, active fault, hindered the establishment of the particularly multidisciplinary and permanent near-fault observatory for many years. But even though we have a very good result, suggesting that the geochemical monitoring is very effective for determining where the active fault is could produce the next big earthquake. So we need to. That's the reason why we are developing the new instrument. So I think that in terms of the instrumentation, we have a chance to collaborate with the EPOS people, but of course, the problem with Japan is that we don't have a kind of the EPOS framework. Most of the data is unified with the JMA, I mean that the governmental-based agency. So when we would like to, which I mean that this is not run by the mainly researchers, but mainly by the government people. Of course, there are some researchers are involved in the committee, but it's not so strong. So in terms of at the moment, I think the next step for the further collaboration is to be the MOU between the relevant university or institute, which runs the NFOs in the EPOS and the University of Tokyo or other universities. And also, we could apply bilateral fund between the relevant agencies in EU countries and JSPS, which is Japan Society for the Promotion of Science, provide funds to our research. I think they are very important to promote the exchange, particularly the instrumentation, that monitoring technique, and also the young people. Thank you very much.
Joao, a very quick comment on the opportunity of signing a memorandum of understanding. We can discuss this, but I think we can do it with EPOS directly. So
yes,
if this is your idea, so we can discuss this, and this can be signed directly with EPOS.
Actually, it is, because we don't have a very good counterpart to the EPOS in Japan. So
yeah, okay,
yes.
But we can sign it with the university, or that's fine. And then maybe we can see if we can enlarge the framework.
Yeah,
okay. Thank you.
Thank you to all three speakers. The next talk is called EPOS and the European Open Science Cloud. Where are we and who are we working with? And the presenter is Alessandro Turco.
Thank you for the presentation, and good morning to everybody. So the topic of my talk, as presented, is the European Open Science Cloud, the relationship between EPOS and EOSC, and the role that EPOS would like to have in EOSC. Before discussing this, I just want to give you a little bit of context. I know that this is the last talk before the coffee break, so I'll try to keep it short. So it's the last obstacle and we can jump it over together. Okay, so the fact that the EPOS has a collaborative approach probably doesn't need a discussion. Your presence here is a proof of that. Yesterday we had some difficulties in putting everybody on this stage to take the photo. So we are really all together and we are collaborating. And we are collaborating to do science, and in particular open science. Solid Earth science is I'm a mathematician, so I'm arrived in this field only recently, but Solid Earth science is your field of expertise, and the recent trends in research usually move the researches from the Solid Earth science to a larger horizon, so environmental sciences in particular with respect to climate change and other issues we have nowadays, and sometimes also to a bigger a bigger topic, a bigger audience, and collaborating with different disciplines in inter and transdiscipline sciences. Looking at the European level, because here we are talking about EOSC, I'm in an international collaboration session, and as we saw, we go well beyond Europe, but for my talk, let's focus a little bit on the EU framework. There are a lot of policies from the European Commission regarding open science that has been selected as a distinct element of research in Europe. And EPOS is one of the pillars in it. It has been established at the NERIC, so a recognized institution, legal framework within the European policies. And moving up the ladder, so expanding the horizon for the environmental science, we have pan-European collaboration like ENVRI, and also national, but always large organization and references institution like NFDA for Earth in Germany and DataTerra in France, for example. If we go to the third level, so we have EOSC, that is the goal of this presentation, but also other initiatives in Europe, data space, digital twins, and so on and so forth. So this is the theory, and the practice is that those initiatives need the funds, and the Horizon Europe is the common ground on which several projects have been funded. Regarding the solid earth science, I would like to cite the GeoInquire project for several reasons. First of all, because it's still ongoing. We are close to the end, but it's still ongoing. Then it's because many people here in the room are within this project, because it has been a very large community effort, and we are very proud of this. And the third motivation is that it's within the GeoInquire project that, and in particular in the Work Package 6, where we enlarged our metadata harmonization activities in a broader space. The same approach has been done at the environmental science level within the ENVRI community, and the ongoing project is the ENVRI Up Next, which is a third one on a series, ENVRI Plus, ENVRI Fair, and now ENVRI Up Next. We are almost at a little bit after the half of the project, and EPOS is active in this project. And now we are starting a new project. It has been funded recently. It has been approved recently, and it will start in September. It's called EOSC Mesh, and it's the project that will bring us toward EOSC. And I will go into some details later on in the presentation. So this is our path toward EOSC, and I would like to point out that our strategy is quite clear, both on the governance and on the technical side. So on the governance side, the idea is that to coordinate and collaborate with the institution and the framework above us before entering directly. So we had some discussion at the beginning at the S3 level, then within the ERIC forum, and within the ENVRI community. And the ENVRI community is where we decided to stay in order to enter the European Open Science Cloud. So as I will show you in a moment, the idea is to have an ENVRI EOSC node. And EPOS will be part of it. It's one of the building blocks there. And we will be there bringing our technical guidelines. So the overall idea of integrating services in order to avoid data redundancy. So we don't want to copy data. We want to bring services to access the data through a metadata harmonization and leveraging existing tools as much as possible. So as I said, the EOSC Mesh project is where we will get the funds to go there. The EOSC Mesh project is a broad project. It's coordinated by AGI, and the idea is to establish and enroll 7 new EOSC nodes, 3 from e-infrastructures and 4 from thematic communities. EMBRI is one of them. Then we have social sciences, biology, and CERN. And within this project, the EMBRI node will leverage the so-called catalog of services as a federating capability. So what is the catalog of services and what are federating capabilities? So the catalog of services is essentially the EPOS platform. So we are using the open source release of the EPOS platform within EMBRI. We are populating it with essential climate variable services, and we are offering it within the EMBRI hub. And this catalog of services will be a federating capability, meaning that it will be made available within the EOSC Federation, not only to serve with the services any scientist coming from different sources to access the essential climate variables, but also offering it as a possible platform to host services coming from different sources. Within this project, we have a couple of scientific use cases to demonstrate the interoperability among the EOSC nodes, because the name of the project, EOSC Mesh, is exactly to express this idea of putting the nodes together, which is also the motivation for which EOSC moved from a monolithic application to a federation. So we have a use case, we participate in a use case promoted by the Central Mediterranean Center for Climate Change on extreme coastal ocean events, and we collaborate there with Global Coast, AGI, EUDAT, and Scholarly Communication. And then there is another use case proposed by DataTerra on the environmental impact of volcanic eruptions, and we will be there, of course, with DataTerra, AGI, and Scholarly Communication. In parallel with this project, mainly because we didn't know up to a month ago if it would have been funded, we decided together with the EMBRI board to move in any case toward the establishment of an EMBRI node. And the proposal for the node has been submitted for the second wave of the federation. We are waiting for the acceptance decision in April, and in any case, if it won't be the second wave, it will be the third or the fourth, but we are there to stay, so we will keep pushing for it. And among all the RISE in EMBRI, 5 of them decided to be there since the beginning, and EPOS is one of those. The other ones are Actris, LifeWatch, CEOS, and IAGOS. Within this proposal, we committed to be the main communication contact and to be part of the technical committee. The submission procedure required a single technical coordinator, but we decided that the best within our consortium, we decided that it will be better to have a technical committee, and EPOS is committed to that. Since the EOSC Federation is pushing a lot the idea of cross-node use cases, also here we have some use cases. One is the same as the EOSC Mesh, so the one with DataTerra, but we have another one for data analysis using workflows, together with AGI and FDI for Earth, and also DataTerra here. We want to federate the discovery of environmental data, and we want to cross-node to explore the idea of cross-node semantic discovery and possibly using AI tools in this. Now, this is the plan. This is what we would like, and this is what we'll do. And I don't know if you have this question, but it's important for us to express why are we doing all of this. And the idea that motivates EPOS is to leverage the European Open Science Cloud to bring benefit to our community, so to the EPOS community. We would like to be there in order to foster, to foster multidisciplinary and cross-border science. Okay, that's like, it's not so easy, but it's a common feature of many things. But only being there in EOSC, we can ensure the EPOS presence and leadership in this that is a flagship EU initiative. Through this participation, we are sure that will enable access to partnership and project for all the EPOS communities. And at the same time, through this partnership and projects, we will gain access to computational and storage resources. Together with tools and workflows, I've heard in some presentation, Galaxy and other tool, and this is where the collaboration among nodes in EOSC will be effective. And the most important thing is to monitor and contribute to governance and standard to be sure that the outcomes that EOSC will bring will be in line with the EPOS strategy and the work we have been doing and you have been doing in the last year. So this is the idea, this is the work we are going to do, and thank you for the patience before the coffee break. Thank you.
Any pressing questions or comments? Is there a question over there?
Yes, thank you, Alessandro. My name is Alessandro Rizzo from the French National Research Infrastructure Data Terra. I'm also the coordinator of the EOSC node Data Terra, one of the thematic nodes on the environmental science and earth science. And thank you very much for your presentation. Very nice, very interesting indeed. You put in evidence all the connection we already established and we want to develop in the framework of EOSC. I think that is a great idea to have an ENVRI-related nodes in the EOSC ecosystem. I just would like to put in evidence that probably one point has been pointed out before, probably the gaps to be fulfilled. Indeed, there are some gaps in terms of fundings, in terms of resources. I think that is important to take into consideration, especially if we want to go ahead in this framework. For that, probably one way is also to foster coordination and cooperation mechanism between all the nodes that are in relation to our domains, such as Data Terra, for instance, but also for the marine domains, the digital twin of the ocean, and the emerging environmental ENVRI node. Probably since the early beginning, is important also to foster what we want to do in terms to enhance interoperability, technically speaking, for our communities in the framework of EOSC. I think that is important to have a common voice in this framework, and joining forces is essential for that. And also in terms of governance, because probably we can establish a sort of governance mechanism among these nodes that in relation to the different communities, because Data Terra is not only solid earth, is really environment. And I think that is important also to consider that national initiative that probably promote some resources also at the European level can bring some additional added value to all the resources that ENVRI, such as ENVRI hub, ENVRI cluster can provide to the communities. The final objectives, I think, that is to bring added value to the user communities. And the main point is just to have really an orientation to foster science and to support application for research. Then thank you very much for your presentation. I would like just probably I have a question to you. How do you see this coordination to put in place at the EOSC level if the ENVI nodes will be established in the near future.
Thanks for all the remarks. And regarding your question, I think that it's a path that we will build together in some sense, meaning that starting with the discussion we had for the proposal of the EOSC Mesh project and for the ENVI node, we started knowing each other better and probably going ahead with the use cases, we will enter into better knowledge also at the technical level, together with probably something on the governance side. And so doing things together, it's a way to growing and building this path, because at the moment we are at the beginning of this, and so I wouldn't say anything too precise now. So this is a road we will go together.
Any further comments?
Yeah, very quickly. So thank you for the question. I fully agree with Alessandro. It's we are at our early stage, so we have to figure out how to build a structured collaboration. Let's say that in the case of DataTerra, we are very lucky in the sense that we can start collaborating now in the framework of EPOS with EPOS France. So I will surely leverage on this preferential path of collaborations to build upon this and then also expand to EOSC.
And I will give you just, and then also, I mean, there is the German organization, that NFDI. So I think that there are at least 2 of these organizations that are moving on the path of EOSC that EPOS can very strictly collaborate with. So it's DataTerra, but there is also NFDI for Earth.
Sorry, it's time for the break, but I try my best. So first I will ask, we discussed during the break, and I ask you to dedicate time for me during the break, because I'm part of the Global Coast initiative, and I will be in Merida in the General Assembly next month, and I would like really much to be involved on this user case. That's it.
Thank you. Okay, thank you very much. Remember that there's still, because remember that
yeah.
still are
I'm Annika Sakoria from Helsinki, leading the EPOS Finland. And the EOS case came to our board because CSC is part of the EOS group, mesh group, whatever, and they were sort of interested in how can Finland, how can we be involved in the EPOS Finland in this case? We know we are very well connected with EOS. CSC is part of EPOS Finland, and they are also the ones that were behind UDAT, and now they are in the EPOS mesh. And also the other part is the University of Helsinki is also leading Actris. So we are several things that are connected in here that's why we're interested as a EPOS Finland interest in this case. Yes.
Well, if I may say, the fact that there is a lot of intersection in the EOSC Federation, so different entries, so national nodes, thematic nodes. This is something that we were wondering about since the beginning. One of the question mark we had, and we will be there asking this question. So we want to learn exactly how to avoid the redundancy and exploiting the collaboration in this sense. So personally, I don't have an answer at the moment, but we are well aware of this situation of the interlapping of services and data from different sources.
Yeah, I mean, that's really the point, that I mean, there are so many different enter points, as Alessandro said. And maybe in EPOS, we are in a good position to try to make a little bit of order on this. So that's the reason why we wanted to give this presentation today with this audience, so that we can discuss with you if there are points that needs to be addressed. So that was exactly the purpose. And we hope that in EPOS we manage to put a little bit of order in all this, because it's confusing, I have to admit. I'm sorry to conclude with this, but sometimes it's confusing, and what Anna Casia was saying is a demonstration of this.
Okay, I think we can anticipate a lively discussion at the end of the morning. Oh, sorry.
Yeah, just to close on a more positive note, you may know that in EPOS we are performing a mapping of all the organizations that are involved in EPOS and in EOSC. So from this mapping, I think we can just answer what Didi said, and maybe create a task force or anyway connect better to have a more coordinated approach to this.
Angelo, last question.
Yeah, thanks. Angelo Strollo, Seismology. I just want to go back to the initial talk from the colleagues from Morocco, because there was no time to add on top of it. I think I'm not sure we all got the point there. I think this is the great example that the colleagues are bringing in terms of one of the few countries that already has data into the EPOS infrastructure, from Northern Africa. Some of these stations are already in AIDA and in EPOS since almost 2 decades now. So they have 2-3 stations that are streaming in real time. And the scope here is to find a way to support them more actively, and not that they rely only on one of the EPOS institutions and so on, so there is really more active support there. And I think that's what will be really nice if, I don't know where and which is the right moment, but if you have the possibility to discuss about concrete options, how EPOS and supporting institutions can help North Africa to bring more data in. At the moment, the situation, and also for the tsunami community and so on, is quite bad. Yeah, we have to recognize that. So we have only probably 2 stations, two countries, let's say, Algeria and Morocco, that are really sending data in real time, which are fundamental also for the real-time community and also for the early warning in terms of earthquakes and so on. So this is really a situation we are close by. We have to try to do something to support them. And Joao, what you just did, trying to get support through European projects, I think is one of the things that we should all know that is a target that we should try to all do. But if we have a possibility within the days, I don't know in which slot this may fit, it would be great to discuss this a little bit further. What Gaetano suggested is an important step, also to have joint PhDs and supporting the PhD programs, because the topics are in common. But indeed, capacity building is what is needed there. They need these colleagues, they need support. And I think that's what we have to do if we want to get more data integrated. Most of the times there is willingness to open and share data. And I think what was really fantastic is that from the governmental point of view, with this setup that they have until 2030, there is definitely a written and clear statement about more international cooperation.
Well, I couldn't agree more. We can go back to that discussion at the end of the session before the lunch break, but now it's time for the coffee break. We are almost in time with the schedule. I thank all the presenters to have stuck to their allotted time. And if we stick to the program, we reconvene at 11:45. Is that correct, Lily? Yes. Okay, good. So enjoy the coffee break and see you at 11:45. Thank you.
The conversation.
Because otherwise, the 45 minutes that I'm going to hear, I'm sure there will be difference.
I'll check with the I mean, you can safely say. That's fine. But yeah.
This is exactly what the Alessandro, specialist for and also this is usually the kind of Alessandro. So we will but also if they sunset on the every node, so that every node and then another every node, then all other said want to be there to go and sure that things are going there. So I mean, you can definitely contact with these people as yeah, but you this direct connection, so if yeah, or but yeah, the first thing I know it doesn't sound yeah, so can you connect with the Java and then you go contact with the that's the point. Vogliamo fare una presentazione. Sì, tutti quelli di oggi delle presentazioni di oggi.
Adesso siamo, no, però 13 sì, quando ci sarà lasciamo fare. Yeah, sorry.
No, vuole togliere questo? Dopo. Carlo, il tuo conto di code lo mettiamo qua poi, se preferisci stringo il cerchio.
No, 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 questo...
Può metterlo anche così, dai, così non fa troppo spazio.
Ok, perfect.
So, decided the questions and answers were so interactive.
No,
that
it's
we should
fine
have-
because I agreed with Jacques. I had it, oh, it's there.
Yeah.
Lorenzo, can I check your presentation?
Yeah, sure.
Hey. So, yeah, I mean, it's also, I have to say, I'm really pleased to be over 20 degrees for the first time, I think, in 7 years. Not absolutely cold, but this winter was out of nowhere, 2 months straight of snow and ice. I never saw that. I've been there 6 years, never. It's not that cold because at the end it's it's a CT with the canal scene and not so cold sea. So either you have a very cold storm arriving from the Nordics, the real Nordics, or I mean, as a latitude is not that big. UK, but latitude, it's probably Newcastle or something like that.
So I'm just people.
No. Yes. I uploaded it, re-uploaded it, I think, yes, it's still probably a drive for, yes, because you are uploaded directly from G Drive. Downloaded. Yeah. Because I am the
Where there should be titles.
Yes. We have title in every, or maybe some.
Well, you have time if you want to add them now and resend it to me. I can try and implement it. Unless you just want to say.
I mean, they are fine. The version can they send you a link to my share?
Here, let me see. I just changed the balance.
So I'm sorry to disturb your discussions, but we need to make a start with the next session. So if you can take your seats again. Okay. I accept the early career scientists. If you'd like to just stay here, apologies. I didn't realize you hadn't done your photo yet. But if everybody other than the early career scientists can just take your seats, or at least begin to take your seats. We are just waiting for the photographer to do the early career scientists. So these guys here, yes, please. I think it's shipped out ready, because my son is this age and they all communicate. Goodness.
Yes. So tall people in the back.
I'm going to move out of the way. It's a long time since I was in research.
Yeah.
You're not supposed to agree, Carl.
Yeah.
Silly, I'm going to get to sack you.
I'm not there because I'm too early career.
You're closer than I am.
Oh, I don't spray that.
As well. Come on.
Early career.
Yeah, we need to talk about what Carl said to me. Right now.
It's all right.
Don't worry, we'll catch up on time. Don't worry.
I'll fix your slide in just a moment. I have to learn.
Oh, it's paper. Okay, so we'll just let all our wonderful early career scientists return to their seats. So I have to say, Zhao and I were just commenting on what a wonderful cohort of early career scientists EPOS has, and actually how different it is from when we were students years ago, where we didn't get to meet our equivalents from around the world. So it's lovely to see you all here and all working together and collaborating, and we've all been really impressed by the contributions made by the early career scientists. So thank you very much for that. I think they've all managed to find their way back to their seats. So we are, I'm just waiting for Carl to sort the slides out for this session. It's coming. So we're going to continue with the international collaboration session at this point. And in a moment, perfect. Thank you, Carl. We are going to have a number of other presentations. Just a reminder that we plan to have roughly a 45-minute discussion at the end of this session. So if possible, please do try to keep your questions until the end, because we are running a little bit behind schedule now. But if there are some really burning questions after the end of each presentation, then we will take a limited number. But we would like to try and have a broader discussion at the end of the session. So we are going to now move on to our next contributor, who is Luca Rossi, who is going to talk about collaboration with Africa and give us a regional perspective. So, Luca, the floor is yours.
Thank you very much. Good afternoon, everybody. Thanks a lot to EPOS for this kind of invitation. It's wonderful to have the opportunity to share some experience and understanding about risk management with you. Thank you to Riccardo Lanari for facilitating this connection, and thanks a lot, special thanks to Federica, who put me after the coffee break rather than before the coffee break. That's always... let me see, like this. So Africa is a continent where most of the casualties are registered due to disaster. And it's even impacting a lot in terms of economic loss, which prevents basically any opportunity for sustainable development. The most important hazard across the continent, but is the same worldwide, is hydrometeorological hazard. But when the geophysical hazard strikes, they really hit hard. This is a map of the loss and damages for earthquake. We have statistics which are pretty relevant even for landslide. We have some of the most risky volcanoes spread across between Congo, something is in Kenya. So the trend is pretty important. And I say it rains on wet soil, we used to say, no? When things are making more difficult for the people who have very low resilient capacity. How do we cope with that? And this is exacerbated very much from the lack of information. This is an example from the Hydromet network that is covering Africa. I said before, Hydromet is most important hazard in Africa as well as in the rest of the world. And this is the result of years and years of investment from WMO and meteorological institutes worldwide, costing more than few hundred millions, but still the gap is significant, and not only in terms of presence of the infrastructure, but in the maintenance of the infrastructure, because there is no capacity on the ground to maintain and keep this network working in the way it should be to grant early warning system to deliver proper services. The same is, of course, even more relevant when we are talking about geophysical hazard. What is the UNDRR approach in order to mitigate or to prevent as possible this kind of hazard and the risk to take to transform into impact? We are trying to work along these components here, And of course, when you do this in Africa, everything is complicated because of the lack of information. So what we are trying to do is trying to rely on systems which are not ground-based, but something that is very much coming from remote sensing that is operated, of course, from international partners. But yet we need to understand how to facilitate for the partners on the ground, how to access and use this kind of information in the most appropriate way. Copernicus is one area, but of course is one example. But of course, EPOS could be exactly the same system. And this is what we would like to build today: an opportunity for partnership with EPOS in order to create long-term partnership to facilitate access and use to information that can be of daily use for the institution on the ground. This again comes from, as an example, from Copernicus, but because I was not yet agreeing with EPOS the possibility to use a slide on that, I want to consult with you all first. What is important is that the data is not enough. What is important is to build the capacity on the ground to access and use this information in the most appropriate way, to explain what are the limits of this information, to understand that some tuning is needed, and this tuning can be done only in partnership with the local institution on the ground, with the scientific partners on the ground who have been working, even if in a different way of what you are usually probably doing because of the different capacity, infrastructural capacity that are established on the ground. How can UNDRR facilitate this? This is an example of one of the most important programs that is implemented across the African continent. It's called African Multi-Hazard Early Warning and Early Action System for Disaster Risk Reduction. It was endorsed at the level of head of states and head of government across the 55 countries recognized by the African Union under the leadership of the African Union. It established a situation room at the continental, regional, and national level. We have completed the continental and the regional. We are now building the national situation rooms. These are all interconnected through open source system that is common. Of course, if someone has already his own system, is equally good, provided that they give us guidance about how to connect to our system. Data are shared openly, along with standard operating procedure to analyze them, so that everybody get the same understanding on how to use and what does it mean, and how to trigger early warning system for this. It copied very much the model of the Italian, the European Civil Protection Mechanism, and is backed up from a network of excellence, which copies again the network of the Centri di Competenza of the Italian Civil Protection Mechanism, of the Aristotle network of the European Civil Protection Mechanism. Exactly the same. It's copying, adapted, and replicated in the African continent. There is one more step that we are taking, and the step is about engagement of the private sector. And this for multiple reasons. The first one, of course, is because there is a market over there that is able to give us some key information, particularly when you talk about exposure. Exposure is quite difficult to detect from the remote sensing. Something is possible, but it's not accurate as we will need. So the private sector is able to give us some feedback on this. And on the other side, they can be users, and they can help to financially support the further development and maintenance of this system that we are putting in place. Activities. What does this situation room and this network of scientific partners do? A lot of things. This is only one example. They contribute to the generation of multi-hazard probabilistic risk profiles with identification of the potential loss and damage for different hazards, as I was saying, to different sectors. This is important because it gives us the possibility to spread the cost of the sustainability across different stakeholders, ranging from public and private sector. We range from, of course, critical infrastructure, agriculture, health, energy, and many other groups that can benefit of this information and, of course, contribute to the maintenance of the system. Here is mentioned only to risk. Basically, we are talking about flood and an earthquake, but of course the same is applicable to all the other risks that are very spread across the continent. And the idea is that we are not working on project-based activity. We want to create an overall program, and there are more opportunities to contribute to this program according to your role, capacity, system. But the point is that everything must be accompanied by the opportunity of long-term partnership to do some job shadowing to the local partner in order to create a long-term cooperation in order to build the capacity of the scientific team, together with them build the capacity of the institution and ensure a continuous development of tool and services, operational services to this institution. Those are a few of the opportunities that we have in order to engage with these different partners, the different areas. It ranges, of course, from the early warning system, but it engages also all the part of land use planning, the resilient recovery after disaster strike, capacity to inform the management of these how these groups should be organized and manage their capacity and resources in order to be sustainable in the long term. This is just an example of one project that we received recently from the European Union, which help us focusing on the part of the early warning system, but is also at the same time building the capacity of the other ministries in order to use this information to implement their regular activities out of the emergency. This approach has been endorsed at the global level last year during the Global Platform for Disaster Risk Reduction, which was hosting also the first global multi-stakeholder forum of the Early Warning for All initiative. It's all of society approach, and the whole of society is not only the society of one country, but is the society of the globe at the global level. So all the different partners convened together, committed to invest their own resources and capacity in order to create this long-term partnership to facilitate the resilience of this country, and at the same time to open a new market for the international partners who wants to engage across the African continent. I think I will leave it here. Thank you very much.
Thank you so much, Luca. I don't know whether there are any quick questions at this point. Unless they're pressing, it would be good to hold them till the end. So we're going to move on now, and we are going to hear about the partnership between EPOS and colleagues in Africa. And in particular, we're going to be looking at co-developing open source frameworks for Earth observation data and how this relates to disaster resilience. And Mohammed, I'm going to invite you to the stage.
Thank you. Thank you. I'm Mohammed El-Gabri. I'm from the African Disaster Mitigation Research Center. It's a Center of Excellence for African Union in Disaster Mitigation Research. When I was invited to this, I was thinking which context I should start with. And I already had another presentation, but when I went to upload it, I found Luca's presentation and found this is perfect. He paved the way to get into a very specific case, because as you see the complex context in African continent and how diverse the situation from side to side. So I give my presentation here about a case from Sudan. All of you know the situation in Sudan. This is the Radiance. This is some Earth observation, remote sensing data. Radiance for Khartoum, the capital of Sudan. It was a city of about 6.5 million inhabitants. This data from one night before the start of the war in 15th of April, 2023. And this 1 year after. And you can see how the city has shrunk, and mostly most of its population has fled out of the city and went to other cities. And the internal displacement in Sudan was estimated to be more than 11 million has to be displaced. And another 4 million has to be displaced out of the country. This is another city, Port Sudan, which was almost the only city which was safe from the battles going there. And you can see that this is again the radiance remote sensing data, just the image for the city during the night. So you see how the lights are growing of the city. So this Port Sudan city was 500,000 inhabitants. And after the war in 2024, it became 1 million. So the population has doubled. So due to the ongoing war, the vulnerability, especially the societal vulnerability, has increased because of the mass displacement. Unfortunately, in August 2024, there was flooding in the Red Sea region. And the main dam, which is called Arbaat Dam, which is supplying water to Port Sudan, has been collapsed due to the flooding. This has triggered a lot of damage along the villages and lives downstream of the dam, and disturbed the main clean water source for 1 million inhabitants. This has triggered epidemic of cholera. So what we can see here is a very clear example of cascading hazards. We are in a war or in a conflict area, we have flooding, and we have epidemics. So the hard question, can open science break the cascade? To answer these questions, I was lucky to have some Sudanese researchers which has fled from Sudan to Egypt. So we got them as guest scientists in our center. And one of them is El-Haj Musa. He's a geophysicist from Sudan Geological Research Authority. So the next slides is generated by him. So El-Haj, he stayed for 2 years with us at Admire since 2024 to a few months ago. And he was from the Blue Nile area. He was in Port Sudan when the war started, so he couldn't go back to his family. And he came to Egypt. And he stayed 2 years until in the late 2025, he was able to go back to his family in the Blue Nile. So when he started, we just provided him the tools. So he had some courses on GIS, on Python, and on using open source data of remote sensing. And we started to study the dam situation, and we found that the operator was keeping the dam filled because they were always concerned about securing the fresh water to the city. But it happens that the flood happened and it's overtopping the dam and it's collapsed. So what El-Haj used, he used meteorological data, he used open source model, RRI model, hydrological model, rainfall data, and we stopped 2 weeks before the collapse. So we tried to predict what will happen in the next 2 weeks before the collapse. But he succeeded to build a prediction model for the next 14 days that he expected that the amount of water coming to the dam is huge. So if the operator knew this information, they could drain the reservoir, but they didn't use this information, and they were in dilemma to secure fresh water to the city. So the answer is yes, we could stop this cascading. We could stop cholera if we could stop the collapse of the dam. But firstly and primary, we need to invest in human expertise. Early warning systems is not only about equipment providing data, but about persons have the capability of using this data. And not only this, but if we could use the information in hand now and provide the right tools to the right persons, this could be a good example of providing early warning for all, as UN initiatives highlighted. In fact, El Hajj continued with us for another year after this, and we had a training course for our 20 African, not scientists, because in this course we didn't call for scientists, we called for operators. We call for engineers from municipalities, we call from geologists, for different persons. What we did during this course that El Hajj and other colleagues has provided their experiences. And in the last 3 days, we asked for each of them, let's provide your data. Bring one case from your country, bring open source data, use the tools you learned, and try to apply this. And the results was really magnificent. So what I can see as a synergy between EPOS and what we are doing is Admire is open source data platform. EPOS is already having large data, and there is other large data available as well. This has to be joined with a capacity building in order to move one step toward capability building. And in capability building, it's not only about command or big rooms with big screens with information. It's very important, and I can see the efforts is going on, but there is another efforts need to be invested into, I don't want to say a small scale, but let's say on larger scale, let's say democratizing early warning, bringing early warning to the levels of operators. So we need to provide the right tools and the right data to everybody in order to build our resilience and breaking the cascade. Thank you for you, and looking for discussion later. Thank you.
Thank you so much, Mohammed. I think that presentation illustrates the impact that open data and open science can have for people who are having that real world experience of disasters within their daily life. And I think we shouldn't lose sight of the potential impact these activities have. So thank you, Mohammed. I think you brought a very real example of the impact that can have. We're going to move on to a related presentation, actually. So we're going to hear from Lorenzo Solari, sorry, Lorenzo, and co-authored by his colleague, Jose Miguel Rubio. And they're going to talk about the Copernicus in situ component. So Lorenzo, thank you so much.
Thank you for the introduction and for inviting me. I have to say it's a pleasure to be here in Cagliari, since I have more or less 20 degrees more than in Copenhagen right now. So it's really wonderful. I present myself. I'm Lorenzo Solari. I'm part of the team that implements the Copernicus Land Monitoring Service and the in situ component. And my everyday work is actually being the person implementing the European Ground Motion Service. But in my, let's say, spare time, I'm helping Jose Miguel to, let's say, manage in situ. And for this, I will speak about his work, and bear in mind that I may not be perfect as him in presenting it. So let's. Okay, so without in situ data, for sure Copernicus can deliver its product. It's a matter of fact. because we have three classes of, let's say, in situ information. We have observations, we have geospatial reference data, and we have the so-called FRMs, so the fiduciary reference measurements. And they are used for three main pieces of work. Of course, they are of values as standalone observation, and but also they are a matter of fact part of many, if not all, production and validation of Copernicus services data. And finally, they are indisputably important for calibration and validation of satellite sensors, new one and current one. I will have a bit focus on the governance and data access. So as you know, we have the so-called Copernicus entrusted entities that create the data that are part of Copernicus. And they work with in situ data on daily basis. So they are responsible for handling the data, using the data, and so on. In case there is need of overarching structure on top, the EA comes in as a Copernicus in situ, let's say, coordinator, and creates the network between the entities and the service provider and allow that new data enter the Copernicus, let's say, environment. Right now, we are within the last 2 years of the current contribution agreement. So this is the reference period you see on top in the title. And here the in situ activities were defined into 4 pieces. So the state of play that I will present afterward. And then there is the main work on support and advice, engaging with data providers, that is in green because it's particularly relevant for this presentation, and finally data access. Where does the in situ data come from? They come from many different networks at the European, national, subnational level, outside of Europe, but most importantly, also from the research infrastructures for which EPOS is part of. I mentioned the state of play. Consider it as a sort of summary of activities that the in situ component publish every 2 years for each Copernicus service. And the European Environment Agency, where I work, we publish every X years the state of nature, where we say how is, let's say, the environment in Europe. Consider this something like this, but on in situ data. So it will tell you where the data has been used, but most importantly, it will tell you where we have the in situ gaps. I think today I heard the word gap many times because we have them and we cannot fix them so fast. This is a summary. The logos are the Copernicus services. For example, the green one is us, is the CLMS. We have many times problem in assessing data for agriculture or forest national inventories because they are behind the curtain of national laws, and many times these cannot be assessed by even a Copernicus services, or for emergency, very relevant for this, let's say, audience. Sometimes we don't have the near real-time observation we would need. It was mentioned in a presentation before me about earthquake data. And also, without the fiduciary reference measurement, let's say the satellite will fly no matter what, but then we have worst, I would say, calibration and validation of those data. Where all of this information about requirements is stored, we have C-Square. So this is a database. It's essentially our library of requirements that is updated twice per year by the entrusted entities. And also regarding geospatial data, there is the platform that is called Corda. And in Corda, we have both the entry for let's say, hyperlink to resources that are openly available, but there are also some data that are stored there because the national agencies give them to the in situ component for the sake of the use within Copernicus. And this can be sometimes even cadastral map that for some reasons a country do not want to publish, do not want to make them public. All of this, it's, let's say, cataloged within our new in situ Copernicus website. You can also subscribe to it for having the most recent news. And there you have use cases, you have this state of play. There is a lot of reading there. So it's less about data, it's more about also, let's say, seeing the evolution and the life of the agreement with providers and so on. Very relevant for today, as I said, is the concept of research infrastructures, and I will give you a bit an intro to what Jose Miguel and the CLMS is doing regarding research infrastructures. The research infrastructures are, of course, a fundamental part of our network of possible and current in situ data providers. And of course, they are recognized entities that can provide us something that is of the best quality possible and that can help us fill in the gaps that there are currently testified in the state of play, for example. And what the EA is doing is advancing this Copernicus Research Infrastructure Exchange Forum. So it's a sort of working group, let's call it like this because it's probably easier, which is currently under development in terms of terms of reference. And the first meeting was held in November 2025, and I have something about that. So there was this kickoff meeting where 10 research infrastructure were present. EPOS was there together with 4 entrusted entities and also the commission, so DG DEFIS, DG RTD, and DG MARE. And for the EA, the exchanged forum is also a way to see what it is needed now, but also what it is needed in the future for the next contribution agreement that is going to be covering the period 2028 to 2034. And let's say the conclusion of the meeting were that, of course, there is the need of the terms of reference, but also there is the need to focus the work on some cross-cutting topics that I present in this slide. So there is, I think, a lot of concept here, but you can group them into, I would say, practices over in situ data, practices for fiduciary reference measurement, Copernicus label on the data, DOIs, and so on. Then I would say a more philosophical work on the attribution and traceability of the data, the support for sustainability of those data, and also something that is really to the practice of the data access, that is how we can leverage on machine learning in the field of in situ and data gathering or collection, but also how we can define common procurement processes for getting this in situ data. Finally, to conclude, I spoke about the Copernicus strategy. As you know, Copernicus is implemented through the so-called contribution agreement between us as Copernicus Service and the Commission. This is aligned with the multi-annual financial framework. And what Jose Miguel did is to define a Copernicus strategy that was presented at the last Copernicus User Forum that was last Wednesday, in which these are the 3, let's say, priorities that will not surprise you for sure, because they are clear priorities. Of course, data gaps are there as partnership, as the long-term evolution. And how this could be done is through these 5 pillars that are fit for purpose, the cooperation between all the elements into the in situ environment, and the fair and openness of data, because this is, I would say, mandatory for some of the data of in situ. The coordinated and efficient work toward the improvement of in situ, and finally, resilience and forward-looking. Resilience, I think it's very relevant right now because we have political matters that can impact the access to in situ data. For example, because of the, let's say, US cuts, many of the in situ data that are from the Pacific, from the buoys, were in danger because NOAA got a lot of these cuts. So this could be a problem for those Copernicus services working with this data, because we don't have plan B there. So these are the data. If we lose this data, then it's a problem. Then this is a risk that, of course, we need to address now and beyond 2027, beyond 2028. With this, I conclude my presentation. Thank you for the attention. This is the QR code again to the in situ website. Thank you.
Thank you ever so much. So thank you very much. Very much appreciate that, Lorenzo. So we are going to move on to the last presentation in this session. This is an early warning to all of those who have spoken in this session that the large number of chairs that are now up here means that we are going to invite all of the speakers to this session to come and join us on stage after our final presentation, so that we can then move forward with our question and answers and our discussion. But before that, I have great pleasure in inviting Monique Bossy to come and talk to us about the Einstein telescope. I have to say I knew nothing about this until I started researching the relevance of Sardinia to this meeting and different activities that have happened on the island. So as I mentioned earlier in my initial presentation, I took front and center stage at the G7 meeting on large infrastructures. So I'm really looking forward to your presentation, Monique. So please come and take the stage.
Oops. Thank you. Thank you very much for inviting us. Yes, indeed. I mean, it's a pleasure to be here in Sardinia, to be here with you. And yes, Sardinia, it's a bit tricky because it's one of the candidate sites, but this won't be touched in my presentation. So today I'm here as part of the scientific collaboration. I will present you the Einstein telescope and the collaboration with the EPOS ERIC. And the other candidate site is the so-called Dutch proposal. So we are still in a little bit of competition, but this is not part of my presentation today. Okay, so the content of the talk would be about, as I said, introducing the Einstein telescope, because as you said, it's not for granted. I mean, we do not give for granted that everybody knows the project, the challenges that we are facing, and mostly the collaboration that we already started establishing, but that we want to reinforce, because it's a huge part of the work that we're doing. I myself, I am in the National Institute for Physics, and I have a background specialization on setting up large research infrastructure. So I'm not a scientist. I'm here to present the project itself. Okay, so you know that usually takes a long way for research infrastructures to be established. In this picture, you can see the pave that He is behind our shoulder and also a little bit of what is in front of us. So I won't go into the details of all the different steps because I'm sure you're familiar with the process, so to say. But I will just highlight a couple of turning points that really marked the story of the Einstein telescope. So the first one, which is related to the scientific achievements, dates back actually to 10 years ago when the first detection of the gravitational wave was, the first gravitational wave was detected by two instruments that are operating now, one in the United States and one here in Italy in Pisa. And this marked, of course, a huge milestone because actually, as my scientist colleagues like to say, they were able to prove that Einstein was wrong because hundreds of years before, in 1915, when Albert Einstein made his theory about the existence of gravitational wave, he actually said, or doubted actually, that we would ever be able to build an instrument with such a sensitivity to detect this very, very weak signal from the remote universe. And actually, as I said, 10 years ago, we celebrated the anniversary 1 month ago. The first gravitational wave was detected. And that, of course, is the huge milestone that opened all the, let's say, following steps and following also, I would say, acceleration that we are now experiencing in the project. The second turning point is entering the S3 roadmap in 2021. So as you said, being on the S3 roadmap, it's an important asset for all European projects and international projects because it actually frames a position that is important also at national level and international level. And now we are in the phase of maybe converging, hopefully converging, I would say. The board of the ministries, the governments, is now taking actions to publish the call for bid. As I said, there are two competing candidacies. So hopefully by the end of this year, the call for bid will be open. And in, let's say, roughly 1 year, we will have a decision on the site for Einstein telescope. But as I said, there are already operating instrument observatories in the world. There are 3 interferometers, one in Italy, Virgo, which is near Pisa, LIGO in the US, which is a double-site interferometer, and one in Japan, in Kagra. So why do we need a next generation? Because of course, as I said, the signal is very, very weak, is very, very feeble, and that major and let's say bigger sensitivity is needed to explore more, to know more. So this Einstein telescope will actually be the 3rd generation of gravitational wave observatory, but with at least 10 times better sensitivity. So the it's a potential of knowledge and potential of discoveries that can be made with this new instrument is, let's say, unmeasurable with the instruments that we are running now. There are, of course, limitations, as I said, of the current detectors. That's why we are, let's say, engaged in this new challenge and endeavor. And also, and I think this is one of the major outcomes of building Einstein telescope, is the opening of a new brand of science, the so-called multi-messenger astronomy, where the different branches of astronomy, astrophysics, nuclear physics, and so on, will be working together also with the other type of telescopes, radio telescopes, that will be able to work together to enlarge the knowledge of the remote part of the universe, of the stars, of the cosmos. So this is really the big outcome of having a new instrument. Of course, not to mention the industrial spillover, the scientific spillover that will result from the construction of the Einstein telescope. When I was thinking about this presentation, I thought that a poetic title would have been like listening to the universe from the underground, because Einstein telescope will be built underground. So there are open discussion on the funnel geometry, a triangle or a double L, double site, single site. So there are some fundamental aspects that have still to be fixed. Nevertheless, one thing that we know for sure is that it will be underground, and it will be huge. So it's 30 kilometers of tunnels. It will be the largest vacuum system, larger than CERN, and it will be between 100 and 300 meters underground. So listening to the universe from underground, of course, implies that the data and the characterization of the site from a geophysical point of view should be very accurate. And here is why the geophysical and geologist community is already collaborating with Einstein telescope. For sure, at national level, INGV is part of the Italian collaboration, because it's the second, let's say second in parallel, not second person second, but is the second pillar on which we build our candidacy, and the same applies, of course, to the Dutch candidacy. So together with the detector design, the characterization of the site is fundamental for us. So what is actually the way forward that we would like to reinforce in the collaboration with EPOS? So Einstein telescope is already cooperating with several large research infrastructure from different aspects. For example, for CERN, as I said, it would be the largest vacuum system. So we need to cooperate with CERN to understand better, to also design together all the in part related to the engineering of this huge vacuum system. We are cooperating with other telescopes, for instance, the ESO for scientific purposes, in particular, for instance, for the multi-messenger astronomy, and also with other infrastructure that might be different sites and size. For instance, the CTA, ESS, and SKA, because we have to learn which are the good but also the bad practices when it comes to building such a huge telescope and interferometer. And of course, we also need to cooperate with the scientists of the solid Earth. We talked with Lily also during the G7 that has been mentioned before, because talking as Einstein telescope collaboration, we do think that cooperating with science, with the EPOS, is fundamental for us. It's a large, renowned, and let's say European infrastructure, and that's why it is for us of paramount importance to establish good contacts and good collaboration. And we already have taken some concrete steps. For instance, Al Pedersen, that is from the EPOS community, has been appointed as external expert in one of the working group that are now working on the site characterization. To underline once again the importance of having experts and scientists from the solid Earth scientific discipline that help us to define the best site to host the Einstein telescope, because this is what actually the scientific community is looking at, building the third generation of interferometer in the best site possible, in order to have these, let's say, the better performance possible from this new instrument, which will be also an engineering, scientific, but also an economic, financial challenges, because it would be quite, let's say, a commitment to build it from the member states. And of course, in order to do so, we look forward for a long-term interdisciplinarity collaboration with EPOS, ERIC, and other infrastructures, and also, of course, eventually data sharing in order to be able to be really interoperable. We heard before a presentation from the EOSC, let's say, opportunities. So this is also an aspect that we would like to explore more. This is it from my side. I'm here, yeah, if you have any questions, I would be happy to answer.
Yes, sure. Thank you. So we're going to have a slight pause just while I gather the podium is going to leave the stage and we're going to get the extra chairs that we need.
To enter.
So if I can invite all of the speakers for this session to join us on stage and take a seat, please. Thank you, Carl. Thank you. Okay, so once we have everybody on the stage, the purpose of this session now really is to build on all the diverse presentations that we've heard from our different contributors. So hopefully we're going to get a couple more microphones in a moment. So do we have everyone?
Yeah.
Oh, Lily's going to do the roll call for me. So we've had a large number of quite diverse presentations, but all of them have illustrated the importance and the value of collaboration at the national, regional, and international scale, and the role that EPOS plays in these different collaborations, but also the added value that it is bringing to the not only to the research community, but also to society as a whole as well. But I know a number of our speakers didn't get an opportunity to take questions. So I don't know whether anybody wants to kick us off. Oh, okay. Daniele, we'll start with you. There are roving microphones coming. So if we can start here, please. Thank you.
So thank you. All very interesting presentations. I have basically two questions. One for our EarthScope colleagues. And the question is about the business model behind the usage of Amazon, I think, for storing all that data and also for processing all the data, because you mentioned a terrific amount of piggings and also of earthquakes localization, and assume it has a cost. So it would be very interesting to articulate a little bit on that. And the second question is for our colleague Mohamed Admir, yeah. And yeah, it's about how do you think we should proceed for if we want to do something pragmatic and concrete? Are there pathways of collaboration between Admir and EPOS? And if so, yeah, just some suggestion to maybe kick off some potential collaboration. Thank you.
On the Amazon business model, I guess, I don't know exactly what you want to hear, but our choice was driven by, I mean, anybody makes these decisions based on cost and political considerations. And for us, it was cheaper. And then we had in the United States, at least, we have political pressure to move into the cloud because Amazon provides a government section of the cloud. So it kind of relieves some of the pressure that people feel like when you go in the cloud, do you own the data or not own the data, all the security concerns. So for us, it was cheaper and in the end, better for us politically to move into the cloud. I don't know if that works for everybody, or I'm sure it doesn't work for everybody. But we did an extensive analysis, and that was the best path for us to go in. And when you do the cost analysis, you have to be careful. Like when you put everything together, it's really hard to beat the cost of the cloud in any model. They just do it a lot cheaper than you can do on-prem until you get to some magic number, say 20 petabytes. Then you can start affording to build your own infrastructure and the people you need to maintain that infrastructure. Did I answer your question?
What was the expensive thing, the storage or the computation? I've heard stories of basically providing storage almost for free while charging all the costs on the computation. Is that true?
Yeah, for us, definitely true because, well, at least currently in the model, Amazon has a open data program for most of the science data, so we don't actually have to pay for any storage. We do keep a copy of it in a different place. We pay for that. That's sort of our backup. And I'm not sure we really need it, but people feel better with it. And so right now the cost is in operating the services and the computation. And then those can be expensive, but I'm just saying, like maintaining a database, keeping it alive, all the APIs, egress, which people talk about, I should say, when it's in the open data program, there's no egress cost either. So it's really just the cost of computing and the space it takes up to keep it persistent.
Yeah, thank you for the question. And I think it's the hard question because as a scientist, I always like to have more data, to have new stations, to increase the data. But on the other hand, you have to think about the context. I gave the example of Sudan because I think maybe about 12 countries in Africa are already in conflict. So you need to operate in this condition. We will not operate in the optimum conditions that, okay, everything is good and you have enough financial resources and you have flexibility to move, you have signed. This is not the case. And sometimes you have the money, you have the resources, and you are not able to go to the location to erect your station. But does it mean we will not provide some sort of mitigation tools to the community? This is a hard question. So in my view, we can start by what we call building capabilities. Building capabilities is joining the capacities with what is available right now. It's some sort of, let's say, zero cost of early warning. So use what you have with the least, because on the other hand, when you go to this situation, you will not have a cloud, you will not have a wideband internet connection. So you need to work in a very limited resource environment. This is a real challenge, and I believe this is what I tried to reflect in the document for the project we are applying for, that we need to work with this. We need to work with these tools in this context. And I hope we could find an answer to your question.
Thank you. Thank you for the answer. Just maybe some more background and details and scoping. How about setting up, for instance, training programs, leveraging on the existing NGOs that work in the place, or are the other types of organization? Is that something doable, you think?
Yeah, this could be one aspect of the things that we have to use already. The projects which previously run in Africa, the NGO, the initiatives which is run either in UNDRR with African Union, And we have to go into another layer, as I said, to the operators. We needed to provide these tools and information to the operator who was operating the dam at that moment. If he had this tool, he could take the right decision. So that's part of the not dilemma, but challenge to find the right persons. In the last course, I showed you, for example, we had officers from migration. And for them, we have to give them tools that suits their needs. They needed GIS, they needed mapping, they needed this information they need. So always you have to search for the right person and the right tools to provide to him.
Yeah, I have a comment and a question, maybe on the same line that Daniele just posed. So how our collaboration with you can be actually put in practice? For example, with our colleagues in Morocco, it's clear. So they are already trying to share and sharing data. So we have a topic, a clear topic in which we see how EPOS can collaborate with you, not only in seismology, but in tsunami and GNSS. So we have a clear field in which we can collaborate, and then we can expand, of course. So what we would like to try to do, and this is a question also for Luca, so how can we actually build these bridges that we were talking about it? So which are the bricks that we can bring to build the bridges, the bricks that EPOS can potentially bring, yeah, with Admir, and also I mean with what Luca was presenting, because we really would like to go a step further. So we know each other, we know what we are doing, and I hope that this week helped all of you to understand what EPOS is doing. But now we really would like to go a step further. We need to build something.
Okay, from my perspective, we have two things. We have to build some tools which is optimized to the context. So some online tools which minimize the usage of internet. So let's say some sort of cloud solutions which will be available to everybody. Tools which I can run my software or my analysis easily on a cloud without using a wideband internet. The second aspect, of course, is capacity building, is engaging with trying to locate the right persons and engaging them into the usage of these tools. And on the other hand is multilingual, is providing these tools and this training into the local languages. So I give it to Luca now.
Thank you very much. And let me start with a comment on your previous intervention. I fully agree on what Mohammed just mentioned. And on top of this, we should add another layer. It's not only about customizing the tool and the information, but it's really explaining to the user how this is built in order to ensure there is ownership and trust to use it for a decision, because this is one of the key points that we have seen as an important challenge in promoting our services across Africa. In terms of how EPOS can be integrated into the system, what I was showing were two, let's say, platforms, which is basically a unique platform, is the AMEWAS program, which is backed up from the Network of Excellence. So we can include the EPOS data that will be available or open for exchange into this network that we have in the open source system that we have in place. It can be used in many different ways. So what we are promoting at the national and local level is either the installation, physical installation of this system if it want to be operated by the authority there. But there is also an online version which doesn't take much band to be used. You get the credential, you log in and you use it. of course, either if you are a partner or if you are an institution that can use it. It's not completely open to the general public because there are some sensitive information over there. So we need to comply with some of the data policies that are established by the owner of the data. And in some cases are national disaster management authorities, in other cases are research center or private sector. So, but it's very easy to enter into these things from the technical point of view or technological point of view. What is more important from my point of view in order to ensure that this has an impact is exactly to train these people, to inform them about how this information is built, what is the uncertainty attached to this information. Is always the same level of uncertainty, or there are different level of uncertainty because maybe the information or the information that we are providing is composed of different elements, and sometimes not all the elements are there to beat that is information in the same way. So they have to be aware of what they are using to trust it. And of course, there should be degree of flexibility if they need to customize this to their specific needs and capacity, because not everybody is having the same level of understanding, the same level of technical capacity, the same level of scientific knowledge in order to make a proper use of this information. Thank you.
Okay, maybe I can give a little bit of background of what EPOS has been doing. We started in 2022 interacting with earth sciences research community in Africa through a dedicated workshop. It was actually it was called first EPOS International Conference. It took place in the Cape Verde Islands in 22, and we were able to bring together a quite comprehensive group of colleagues from different countries in Africa to identify or to ask them to identify their where the bottlenecks were, where the challenges were, and basically how EPOS could help. More recently, we have engaged with the UNDRR program. Concretely, last EPOS Days, we had Gatpo Kai was the coordinator of the program of the UNDRR program for Africa. We made very important contribution, and over the last year, we've been interacting also with AMEWAS. We had a series of video conferences with the colleagues from AMEWAS, basically, again, asking the question, how can EPOS help? One of the limitations that was identified by the colleagues from AMEWAS is that they were getting little input in the area of earth sciences, whereas for other risks they were better provided of input information. They identified very clearly that challenge. And one of the things that became quite apparent to me was that there was a sort of disconnect between this top-level organization, AMEWAS, and the African research community for earth sciences. And this is a problem that we were also able to identify earlier in the workshops, in the conferences that we had in 2022. It was basically a problem of scale. There are many institutions at national level that have limited resources, but they are active, they are relevant players. But what we identified as a possible way forward was to promote and help organizing these national level institutions into regional organizations that might then interact more easily with the AMEWAS and other top-level organizations. And I agree 100% with what Mohammed was saying, that we need to reach to the operators and help assist the operators doing their job, because they are the key ingredient. We cannot stay at the level of the researchers. We have to go and do the training. And just to finalize, Mohammed made a very interesting remark just at the end, which startled me, which is the linguistic issue. Actually, over the last 4 years, I've been engaged in programs supported by the Portuguese government to train technicians, so again, the operators, in Portuguese-speaking countries. And I always ask myself, does this make sense? I mean, should we be really doing this based on the language? But the truth is, when you are operating at the level of the staff, not the scientists, but the staff, language can really be a major barrier. So it is actually a very relevant point that sometimes we tend to forget.
Can I reply on this? And let me start from this last point. I said earlier, it's paramount to reach out to the very local level, the operators on the ground. And this is why we engage them both in the designing of the emergency response plan that use these early warning messages for triggering the operation on the ground. On one side, we do simulation exercise on the ground, which activate the entire chain of responsibility from the level of the African Union Commission down to the policeman and the mayor or the head of the village on the ground in order to better articulate the response. We organize through another component which is called local level resilience or making city resilience. There are a number of initiatives that work in the different sectors at the very local level about how to plan and how to react when these messages are reached. We run programs to inform the population and to make understand this kind of messages and why and how they should be shaped in a way to be actionable from them, to understand and trust the information that is given. A different thing is about what you were mentioning earlier about the engagement of these scientific teams. I don't want to enter too much into this because an issue of geopolitics, and I don't want to, let's say, enter into the geopolitics of the African Union with other member states, or so. It's not my business entering into it. But I can offer you a solution, a practical solution at this stage. The network of excellence that I was mentioning does not respond to that kind of geopolitics and dynamics that are happening across the continent. So it's an easy way to enter. You can participate in their workshop, exchange with them, carry on training on how to access and use EPOS, how to get data from their side that can feed the EPOS database in order to further perform and improve your analysis and capacity to run models or whatever. So this is an opportunity that I'm putting on the table, and that's what I can do on my side.
So I think we'll take some more questions from the floor. Henning, I think you've been patiently waiting with the microphone down there.
No problem. But are we ready for a completely different topic?
Yes, I think so. I think we can
because,
move on
I mean,
to the
it's
next
not,
topic.
It's not really a question. It's more raising a concern triggered by the last talk, and it's this conflict between the political decided super expensive mega infrastructures and our more community-driven infrastructures, because the resources are rather limited. We all see it in our countries. And if I go back to Sweden, for us, for example, membership in CERN, membership in ESS, it's taking half to 3/4 of the entire research infrastructure budget. And for the smaller infrastructures, I mean, like the Swedish contribution to EPOS and all the other networking and international collaboration, there's hardly any money left, and it's hard competition. And we really have to think about how much of these mega infrastructures can we really afford without losing everything else. And I mean, it's nothing against the Einstein telescope and nothing against CERN in general, but I mean, it's important, but if we get more of it, we won't have anything else.
Yeah, well, I couldn't agree more, Henning. I won't go in for the reasons why that I couldn't agree more, but I think, Lily, you wanted to comment? Okay. Yeah, I mean, I think this is always going to be about demonstrating value. Even this morning, I saw in the news in the UK that the UK government is currently reviewing our contribution to CERN, which is creating a significant backlash within the astrophysics and the particle physics community. But I think it demonstrates that at the political level, we are needing to demonstrate the value of our national involvement in these different initiatives, whether it's the sort of the super infrastructures, whether it's CERN or various large telescope initiatives, or whether it's the research infrastructures such as EPOS. But the thing we're always having to demonstrate is the value that it brings to not only to science, but to society. And certainly in the case of CERN in the UK right now, we are having to, well, the particle physics community is having to demonstrate why our involvement in a large infrastructure like that, what the value it brings to our economy and society. So I think we have to talk about the value it brings. And I think we're able to do that for the smaller infrastructure as well as the bigger infrastructure. I don't know whether anyone else on our panel wants to comment. Yes, please do.
Okay, no, thank you. Yeah, so yeah, I think that we are one of the mega large infrastructures. So of course, I cannot talk for ESS or CERN or FCC or the new developments that CERN is planning. But when I give this kind of speech, I always start with a question: why do you think that two big, let's say, groups of countries are struggling to host this infrastructure? It's because okay, well, first, we have to distinguish between the costs, so for the construction and the operating. So construction costs, it's a complete separate topic because this would be carried by the hosting country. So it's not part of the, let's say, collaboration split budget or fees. And the second question is then now, what do you think they're struggling to host? Because it has a value itself. It has a cost, for sure. The estimate cost for ET is around 3 billion euro. So it's huge. It's very expensive. But all the studies that we are conducting now on the socioeconomic return and benefit demonstrate that it has a value also in terms of growth, in terms of employment, in terms of services. I don't know the exact case of the Dutch candidacy, but I can tell, for instance, here in Sardinia, even if Einstein telescope is not here, and I don't know, won't be here because eventually it will be built in Belgium. There are already services that have been created for the population, like high-speed connectivities, streets, hospitals, international schools. So it is, of course, a cost. There is, of course, a competition among research infrastructures at national level, large infrastructure, smaller infrastructures. But I don't think this is the, let's say, the right level of discussion. It's not about competing, the competition between large and small infrastructure. It's really about the benefit that this kind of endeavor can bring to both local level and international level in terms of advancement of science, advancement of technologies, advancement of collaboration, So from my point of view, I would put it on this level of discussion.
Yeah, thank you for that. I think that very much dovetails with what we're seeing in the UK at the moment and the justification of our involvement, our continued involvement with CERN. I think part of that article was also quite interesting because it highlighted the number of scientific discoveries that have been made from blue sky research, which at the time everybody went, yeah, but why do we care? That turned out to be major advances. And in fact, the invention of the computer was one of those particular inventions that was created by blue sky research that nobody really knew what it was for at the time. And we all know what the impact of that has been right across science and society. Lily?
Yeah, I have a comment as well. So I see the Henning's point. Yes, I mean it's clear that I mean we would like not to be in competition, but Henning is totally right. So, but I would like to go a little bit further because I mean everything we said is correct. I mean we should compete in terms of added value and how good we are. Unfortunately, we compete also on resources, but let me bring this on a different level because, I mean, at some point is a political decision. So when the political decision is taken and this is over our head, I think the fact that Monique just said that Earth telescope needs EPOS to be built and actually even to possibly go on. I think this is something that in EPOS we should exploit. So at some point when I go to my country saying, okay, we are investing money for the Earth telescope, good, but we are EPOS and the Earth telescope is actually need EPOS. So if you want to invest money on the Earth telescope, don't forget that they need other research infrastructure to actually be operative, to be built or to be operative. So this is also the level of interaction and collaboration that I see. So when your infrastructure is really useful to another infrastructure, I think we are all winning.
Absolutely, Lily. I think we shouldn't lose sight of the fact that a number of these initiatives are interdependent and that we should be leveraging that at the political level as well. And particularly when we're having those conversations about resources, because, you know, those are the things that the politicians listen to.
So my point is, I think that all of us in EPOS, in our single country, if there is this topic about competition, we should say, yes, that's true, but please don't forget that, I mean, there are other infrastructure that need EPOS. And so use these actually to, for our benefits.
Thank you, Lily. There's a question right at the back that's been waiting a very long time.
No problem. If we are okay.
Yeah, I think I will take. I will keep the mic because I feel that Michele will ask something to me. So anyway, I just wanted to say something from the Copernicus point of view. Of course, in this political context, especially now that there is all the discussion on the next MFF and a lot of discussion also budget going to defense, space, dual use, they are relevant things and sometimes look as as part of the Copernicus entities, we also have a certain limited control of these decisions. But because you mentioned UK, you remember when the Brexit went, then of course also the Copernicus support went out. So we essentially, for the framework contract that we had before the Brexit, we kept producing the data because they were signed before. For the new ones, then UK was not included. And I think it lasted 1 year and a half until UK joined the game because they saw the added value of losing something. I think that's also the important thing, is not only to demonstrate the added value of something that will come, but the added value of losing something to your market, to your network of whoever is going to use the data. And we saw, I think, for the SLMS data, that was quite evident.
Yeah, absolutely. Yeah, the UK is basically joining Europe by stealth at the moment. Don't quote me on that. Michele.
Thank you. Yes, my question was for Lorenzo Solari. Okay, I want to just introduce myself because I work on TCS satellite data. So we benefit a lot from Copernicus program, Lorenzo, you know. But our main benefits concern the data, so the data acquired by satellites. So my question for you is, in your opinion, how we can benefit not only from data but also from services? In particular, we are interested, or the community of EPOS ask us to interact with you in order to, you say that you are the manager of the European Ground Motion Service, how EPOS can benefit from the work that is done within Copernicus concerning services, and I'd like to know something on this. Thank you, Lorenzo.
Yeah, thanks. Of course, the work that you did also in EPOS, let's say that the first deformation map of Europe is also something that you did before the HMS was actually published. So it is part of what we call demonstrators that brought forward also the need for ground motion data at the European level. So of course you are part of, let's say, that process. And the thing is that right now, of course, we have a fully going on project that will last for sure until 2028, and we produce data on annual base. This time, yes, we are late on the delivery, but it's part of the work. My opinion would be that since you have a very well functioning platform that has already insert data inside that are your insert data, if you, for example, demonstrate the need for a certain format, that something is needed, for example, in terms of, we spoke about that already, in terms of WMS or something like this, you can write to me an email and I can make sure that these, let's say, requirements are taken into account for the future. I can tell you that we are in the process of publishing the new data, and together with them, we are gonna have a web cover service of the vertical and the east-west components. So maybe you can use it directly as a WMS service into EPOS, explaining, let's say, also maybe the difference of the two data set. And yeah, that's a possible way forward.
Thank you, Lorenzo. I saw another hand. Angelo.
Thank you. Yeah, I would like to go back to the to Monique and to the Einstein telescope, not about competition, but about how we can leverage on that strategically and how we can also support on the long term. It's clear that part of the EPOS infrastructure, especially the seismological part, is used in the site selection and all the work that is planned until then. Is there anything in the proposals that is also designing and preparing for the seismological infrastructure that will be needed also afterwards for the operation of the telescope, and whether that's an integral part of the proposal, and whether that is something where EPOS can also support, and especially which are the technologies, if it's only the conventional seismic part that is considered, also fiber optic sensing and things like that. If there is any spoiler, we will be happy to hear about that. Thanks.
Okay, no spoilers, I'm afraid. No, of course. Indeed, I mean, when it comes to cooperating, it should be a win-win situation, as Lily was saying. So from our perspective, I mean, counting on the collaboration with EPOS, it's of course a big asset because, I mean, EPOS is a trusted platform or an international trusted platform. So all the studies, the expertise, and the technologies that you can, let's say, provide in order to have the most accurate data on the site selection in this moment are, of course, I mean, valuable for all the, let's say, configurations, national, international competition, geometries, etc. And afterwards, of course, it will be again of paramount importance to have the continuation of such scientific collaboration because first, for instance, the sites have to be monitored because, as I said, I mean, it will be 30 kilometers of underground vacuum system and tunnels. And the vertices are huge cavern, like 10 stories building. So the vacuum underground will be, I mean, the excavation will be huge and the monitoring of the situation underground is of paramount importance. So from a seismic point of view, the stability and so on. So of course, as for the technologies, I mean, I'm not an expert on this, but I'm sure, I mean, that there will be also, I mean, I don't know if it is the right term, but non-conventional or new technologies needed. There are currently also programs funding cooperation with industries to developing new technologies, including monitoring of these aspects that you were mentioning. So of course, there is a huge potential from my perspective to continue. And that's why I would be happy to make clear that the collaboration is for us paramount importance. Not to overlap, not to, let's say, going around and look for expertise that you already have in your infrastructure. And it's, as I said, I mean, it's trustful because it's a European, it's a well-established platform. And so it would be an advantage for us to count on this. And also there will be research centers for the underground studies, for instance, already designed to be part of the research centers that will be established together with ET. So there will be research centers for the astrophysics parts, but also for the underground sciences. So of course, it will be, I think, plenty of possibility to, let's say, reinforce the collaboration that we can already start establishing now.
And I can just add a small piece of information, Angelo, that as you said, the building of the infrastructure eventually will be supported by the hosting nation. So in this framework, I know that the ministry is putting some money also towards through INGV to build a boreal network, broadband network there for monitoring the noise, of course, and they are just making some thinking about the design also of DAS and other infrastructure that will complement this part of then the data hopefully they will be everything open and distributed via the usual channels that we know.
Lauro, that this then will actually remain there. And so EPOS is in a way is already benefiting from this collaboration because we will have new stations, a new site where we collect data that are then shared in EPOS. So I think, yeah.
Thank you. Federica, I'm going to put you on the spot. Federica, obviously, you're running this survey looking at the effectiveness of collaboration. And I just wanted to get your thoughts on what you've heard during the discussion in the session, whether it actually aligns with some of the outcomes of the survey and whether you've got any reflections based on what you've seen on the responses that you've already had on the survey as to whether what we're hearing today sort of aligns with what you've already learned from the survey.
Yeah, I would say it aligns very well in terms of both the interest in expanding collaborations that have shown during my presentation, but also on the topics of alignment, because we have been talking a lot about data collection, so scientific topics, and also on training and capacity building. And coming back to that, I think that we have been talking a lot of creating frameworks with, especially for the African side, for region or continent-wide collaboration, but I think we have to work on two different levels. So on one end, of course, we are reaching out to initiatives that can be representative of large regions or even the whole continent. On the other hand, we need some quick wins to start with, because my impression is sometimes you don't want to grab more than you can chew at the same time. So I think what we need is some pilots, some actions, some milestones that are feasible and that we can show as results to the people we are going to talk to in the future, and have to start the conversation on something we really did. And I think that Lily would agree that in EPOS we are used to do things and talk later. So I think that if we can show some results, we can start from the easiest and the most ready part, and then show some results and go a bit farther.
Yeah, thank you, Federica. And for those of you who are in the room who have not completed the survey, I would encourage you to do so, because I think one of the things that we've heard throughout all of the discussion in this session is the importance of evidence-based conversations, whether they're on a scientific basis or on a political basis, and actually having real data to demonstrate the impact of what we're all doing, not just in EPOS, but respectively in our different initiatives, is really powerful in the different conversations that we're having. I think we're coming towards the end of this session. I'm looking to Carl, wherever he is. I think we're getting towards the end of the session. Does anybody else have any comments, remarks that they want to make? Oh, please do. We do. Yeah, we have a couple of minutes. Please do.
Thank you very much. I'm Marek Lewandowski, based in Institute of Geophysics, Polish Academy of Sciences, and I'm national node for EPOS in my country. And my question, rather affirmative address, is toward EPOS being a member of a sort of consortium in environmental sciences. So I would like to address myself to this issue, because I found in one of the slides that the EPOS is active, or is meant to be active as a partner in the newly formatting a consortium on environmental issues. This is important because the Institute of Geophysics is not only leading the EPOS in the country, and EPOS PL, but also because it also leads the actress, and also is involved in SIOS. So these three new members are mentioned in your presentation, and I was very happy about this. But also I noticed that this issue, a cooperation between research infrastructures belonging to different domain, abiotic and biotic, may be really challenging. And I must admit I made approach myself, because for some years I'm acting on coral reefs issues. And coral reefs is a domain which links abiotic and biotic research very strongly, and it's also very important in the global domain. So I wonder whether there are some talks and some trials to develop a mechanism for exchanging data between all these new partners. Because when I was approaching one of them from biological domain, I was asked whether the infrastructures which will be built during such a cooperation will belong to EPOS or to biotic institutes. So this is problem which I would like to resolve, and I find it myself very important, but also, yes, it's really challenging, and this is what I wanted to say. Thank you.
So thank you for the question. I think one of the important things to mention here is that EPOS is part of a cluster of research infrastructures in Europe. So there is the ENVRI cluster, and the ENVRI cluster is very well coordinated through the ENVRI board, but we also have we've had a series of projects, which I'm going to pass to Alessandro to mention in a moment, which are the current one is the ENVRI Hub Next, and that is actually developing a technical infrastructure that is sharing data across the different research infrastructures, so the environmental research infrastructures in Europe. And I think this kind of addresses the issue you're raising about that interaction and the data sharing between different research infrastructures and the relationship between the environmental research infrastructures in Europe, if I understood your question correctly. I don't know whether you want to comment a little bit, Alessandro, about ENVRI Next, ENVRI Hub and the activities there, because you've been involved at the technical level.
Yes. Well, but I can confirm what you have just said. The ENVRI Hub Next project has just launched its web portal, the new version of the web portal. So if you go to envri-hub.envri.eu, if I remember correctly, or you search on Google, you see the state of the art of it. And from EPOS, we are collaborating. We are maintaining and developing the catalog of services that is an analog of the EPOS platform, where we put together services for accessing data from different arrays on different domains. And I agree that this is challenging. Probably you know way better than me this. And also within the project, we are still discussing with Summarize. The harmonization work is ongoing and it's not finished yet, of course. But yeah, the project is working in that direction with a special focus on essential climate variables, because in order to have a successful project, we needed to focus on a specific aspect, not on everything, but it's a starting point and we will move forward from it. So that's the state of the art there.
Thank you so much, Alessandro. I hope that answers your question. Unfortunately, we've run out of time. And I know we're now between everybody and lunch. But I want to take this opportunity to thank all of our speakers who are now sat here. I think we've seen a very clear picture of where the touch points are between EPOS and a whole raft of different initiatives, but also it's illustrated opportunities for further and more in-depth collaboration with a range of different initiatives. I think we all recognize that we are all facing a number of common challenges where the strength of the collaboration gives us the opportunity to leverage our collective resources, our collective knowledge, our collective experiences. So I hope that this session will stimulate some further conversations where we can identify clear opportunities for collaboration. I know from what we heard about Jem earlier today that, you know, some of these things have actually been stimulated from previous EPOS days. So I think it's an exemplar of bringing people together and having those conversations is the opportunity for us to share our experiences, but build new opportunities to work together. So I want to thank you all. So I hope we can all thank our speakers. So thank you very much. And it's time for lunch, I think.